राघवेंद्र बगीचे में बैठे हैं क्या, घर में? राघवेंद्र, आश्रित,
अरे सर ये कैसा आ रहा है? ये आपका सर कैसा आ रहा है? ये आपका मीटिंग का क्या हो गया? अब सर ऐसा क्यों आ रहा है आपके उधर?
कौन सा, किस पे?
ये कौन?
सुधांशु शेयर कर दिया है ना।
सुधांशु को बोले फोन करके सर।
सुधांशु क्यों शेयर किया यार?
सुधांशु योर स्क्रीन, या नाउ इट्स ओके।
सुधांशु का
स्क्रीन आ गया था यह सुधांशु, यह अभी नहीं।
पटनायक भाई,
यस।
अरे ये शेयर कैसे करते हैं?
अरे अभी मत शेयर करो, अभी मत शेयर करो।
अरे मेरा डेस्कटॉप में पीपीटी पड़ा, मैं शेयर किया, ठीक है?
शेयर किए थे तुम?
मैं शेयर कर लिया था, स्क्रीन शेयर कर लिया था, पीपीटी शेयर नहीं हुआ था ना।
अब एक काम करो, नहीं तो पीपीटी जल्दी मेल में भेज दो आनंद को, मेरे को। अगर
ओके मैं ट्राई करता हूँ।
अभी शेयर मत करो।
कोई बात नहीं, आप लोग स्टार्ट करो, अभी तो है मेरा, मैं शेयर करता हूँ, आराम से करता हूँ, डोंट वरी।
हाँ ऋषि, कोई बात, कैसे हो? ठीक हो? अच्छा अच्छा अच्छा, बढ़िया। मैं एक्चुअली फोन वो जो IMS मिल गया पासवर्ड मुझे। ठीक ठीक, हाँ वो IMS सोसाइटी का वो पासवर्ड मिल गया। चलो कोई बात नहीं। हाँ 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 ठीक है, मिल गया। ओके, तुम रेस्ट करना अच्छे से, जल्दी से ठीक हो जाओ।
शेयर कर रहा है सुधांशु।
हाँ 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 ठीक है।
सब आगे के?
हाँ
अच्छा
ओके।
ठीक है।
अरे ये सुधांशु क्या कर रहा है?
सुधांशु अभी क्यों शेयर कर रहे हो स्क्रीन?
नहीं अभी हुआ कि नहीं, मैं बंद कर देता हूँ।
अरे बंद करो अभी।
कर दिया, हो गया?
हाँ
बंद हुआ अभी?
हाँ हो गया।
सर 45 में कॉल करें?
कॉल किया है अभी जस्ट सर, हम वेट कर, जस्ट सर के लिए वेट कर रहे हैं, डीजी साहब के लिए। जस्ट
एक यूनियन
आगे सर, आगे। यस यस सर,
सर शुरू कीजिए।
सर आगे बस।
महापत्रा साहब नमस्कार।
नमस्कार डिप्टी साहब।
ठीक है आप?
Sir,
Namaskar, namaskar, good afternoon.
we are live, sir.
Okay, we are live now. Let us start the program.
Please
So
start.
very good afternoon to everybody, and I welcome you all for this webinar on winter weather systems and their impacts, being conducted jointly by Indian Meteorological Society, Indian Meteorological Department, and Ministry of Earth Science. Once again, welcome to all the members of this fraternity. As this is already inter season, and we are already in the middle of the inter season, beginning of the inter season, and what type of weather so we are experiencing now, and you just we want to discuss all the aspect of this thing, how we have prepared for this thing, and also how we are ready to provide services for different sectors. Without taking much time, I will request our President IMS, Dr. Mutunjay Mahapatra sir, and also the DGM IMD to kindly give the opening remarks for this webinar.
Namaskar, good afternoon. At the outset, I congratulate IMS and IMD members who have taken this initiative to organize this joint seminar on winter weather systems and their impacts. As all of us know, winter weather plays a dominant role in our socio-economic activities, especially in northern parts of the country. It poses threat in the form of the weather hazards, like sometimes heavy snowfall or heavy rainfall. And also you can expect thunderstorms, hailstorms. So it requires the intervention of the disaster management agencies, press and electronic media, and early warning service providers like IMD, SASE, and the research community and modelers like IITM and 7WF, many academic and R&D institutes like IIT Delhi, and many more. So we thought that it is a good opportunity if we can have some kind of a session on various aspects of winter weather systems and the services being provided for the people, for disaster managers, and general public. So the problems arising due to the winter weather systems are beyond the disaster management. It affects our day-to-day life in terms of impacting our surface transport, our communication systems, power systems, our health and hygiene. And hence, it has got multi-pronged impact. So I'm happy to find that this program has been organized in such a manner that it addresses the requirements of various sectors of the society. I hope the listeners of this program will benefit by increasing their awareness about the various types of winter weather systems, about the various types of impacts, about the various types of warnings being issued, and some kind of do's and don'ts or approaches to manage these weather and climate systems. So I will not take much time. I, on this occasion, congratulate all our speakers, panelists, and the participants in this program. I wish this program to be a highly successful one. Thank you very much.
हाँ सर दिखाई दे रहा है.
Switch on your mic.
फुल स्क्रीन सर. हाँ.
सुनाई नहीं दे रहा है. Switch on your mic.
Now it is okay?
Yes.
Sorry. Okay, so good afternoon. So basically I will discuss the scope and objective of this workshop, and also what are the things that are being done here from our Indian department. As you see, this is the objective of IMS broadly to popularize the science of meteorology, disseminate the knowledge, research activity, and promote cooperation. This is the broad framework of Indian society, and we are doing all these things to propagate meteorology and disseminate to different workers and level different scientists also and students. And in this framework, and if you look at the objective of IMD, you see IMD also is a part of the society, integrated part of the Indian society. And here, the basically to how to warn the severe weathers and also promote material research and all these things. So jointly, we are working together along with Ministry of Earth Sciences to promote the science of meteorology. And in this line, we are working this on very important topic of winter weather system and how it impact the different sectors. Basically, the winter weather, if you see here, the northern India, we are confined in northern India because northern India is a little higher latitude, so winter mainly affect over that. And this western disturbances, cold wave, and after the passage of western disturbances, fog, and also sometimes because of the atmospheric conditions, pollutions, haze, snow, avalanche. These are the main features of winter weather from November to February, we can say. Though during this period, we also get different other weather system like cyclone. As you've seen recently, 2 cyclones were active of Bay of Bengal, Arabian Sea, but our scope is only restricted to the winter system over northern India from November to February. So this is very well known to many material community field persons working in this area. WD, it forms over Caspian Sea and Mediterranean Sea, moves eastward and passes toward northern India and give rise to widespread rainfall sometime. And after that, even cold wave, etc. So this is it can be detected as a low or trough in upper troposphere or middle troposphere. So this western disturbances is a regular feature during the month of November to February. Another thing, if you look at this thing, the temperature, minimum temperature is also during this period, northern India 10 to 12 degree, and sometime it further down to some level minus degree also. So we also experience very cold temperature during this winter over northern India. As already IMD is working for this also to give cold wave forecast that be depending on the temperature departure from normal. So that is -4 to different criteria is there, and if it is very less than the normal, then we call it cold wave or severe cold wave. And this is the right hand side. If you can see the criteria, all these things are available in our FAQ. And sometimes the maximum temperature also reduces significantly, that we treat as a cold day. So that winter, we both cold wave and sometimes cold day are very common in northern India. With respect to climate change, as you saw, climate change basically it is increasing of temperature due to the increase of carbon dioxide and greenhouse gases. So result of this thing, though temperature is increasing, our cold wave here, that's why we are not getting, if you see long-term trend of maximum minimum temperature over northwest India, let us say, we are in fact getting some increasing trend. So since temperature is rising, that's why on trend case, means if you analyze the trend, there is slight increasing trend of minimum temperature as well as maximum temperature over northwest India. And similarly, on if you see here the frequency of heavy rainfall during winter season, this is there is a decreasing trend. This is some research analysis, and we can say with respect to climate change. But and due to this thing, we are not getting any significant increasing or decreasing trend of heat wave, cold wave days. But if you look at the classification or number of cold wave in different decades of a different area, you will get these are area, some area it is having more than on per 6 day per year 6 days are cold wave percent, and totally more number which are the area you can see here having more than this decade 50 years episode 5 decades. So if you see on average some higher things are Rajasthan, Punjab, Haryana, these are the stations where more thing, and there are even south is also penetrate towards south, and some less number of area or days are with cold wave that you can get from other region. South. And now with the sophisticated modeling thing, we have already adopted a very high resolution models, high resolution regional model, high resolution global model, and high resolution ensemble forecast model, and we are running 4 times a day. Then also we have the extended range coupled modeling systems, and we have the seasonal forecasting system. So now sophisticated models are being operational in IMD, and in addition to this modeling aspect, improvement is also there in the forecasting, monitoring, and radars. That's why combining these two things, we are generating now several type of products which can be utilized for our winter weather monitoring and prediction. And all these products are being hosted, and we will listen to our colleagues from NCModel and IITM. They will also be presenting their means what are the specific products available for when winter weather monitoring and forecasting. And if you, some of the something I am highlighting here what we are using NLP model products for our forecasting, the temperature inversion, temperature tendency, the minimum temperature forecast. Means we are going for 5-7 days forecast, and also relative humidity. When high relative humidity means lower wind speed, that is combined, that is favorable for fog type of condition. So these model products are being widely used for monitoring such events during the winter season that we are running operationally by IMD. This is just meteograms, some location specific. We can see how this different level, wind speed, etc. That is also useful for the aviation purpose. And as I said, aviation purpose, the different height, flight level, convective cloud cover. This is 0 degree isotherm, middle level, lower level wind. So all these products are being available, prepared NLP modeling thing center, and it is disseminated to all forecasters, and they use for monitoring of this weather event. And as I said, IMD integral part to provide the service, and specialized service forecast and service are provided. If you see here, all sectors we are approaching, and now if you, there are air quality forecast, then the SILUM, that is model for give air quality forecast, and also power sector, highway sector, aviation forecast. So these are sectoral field where we are providing services. So this platform we will go toward the second part of the our session. We will be discussing how this is very important, particularly the winter weather for this sectoral application. So that we will discuss here. And as I am sharing, this is some just recently 2 days back only the forecast how our Met Center in Srinagar and they provided how the snowfall was there, and based on the forecast, so they means timely providing the guidance and forecasting to all the users over that about the snow and likely avalanche also. So this is a very good thing, and our colleague from SASE also is there. We will listen to them to get more details about this thing. So this is how the MC is providing winter weather forecast during the snow period. And as I said, the air pollution is another part, because air deteriorate because of winter favorable condition inversion. So that's also we are providing the model forecast guidance based on the SILUM model that is jointly done to the Finnish Met Department, and MOS other institutions are working, and that we are providing the air pollution term. And in addition to the short and medium range, we are also running operational extended range forecast model here. So that also give long term cold wave here, or sudden jump in minimum temperature, sometimes rise in temperature, sometimes fall in temperature. So that is also very well predicted with this extended range forecasting system. And if you see this observed temperature anomaly very cold. So this we are getting 1 week in advance, 2 week in advance. So that type of conditions are available. At least favorable conditions are predicted. Means temperature conditions are very well predicted 2 weeks in advance. And now because of the demand of temperature on smaller scale, we are also going further experimentally. We are preparing the district level forecast about maximum temperature and minimum temperature and their departure. So if you look at this is a current forecast. That means here very low temperature in this week one, most part of northwest India, but we are expecting slight increase in minimum temperature here in next week. So this now smaller scale forecasts are being available for user community. Then part of the thing now what we are going to discuss is the impact. So since impact is and IMD has already ventured into impact based forecasting for cyclone, heavy rainfall, thunderstorm, and slowly not only how the monitoring and prediction of the severe weather, but how it will impact. So actual impact based forecasting now we are starting. So for that, the service sectors people, we have to work together with them. That's why today we have invited all these sectors, those who are related to the winter weather. And 5 sectors here we will be discussing. In the transport sector, as you say, transport sector means the surface transport sector. This is because of fog, etc. Lot of disturbances are there to train and road services. So that is one sector. Agriculture, very frost conditions sometimes deteriorate the crop also, and sometimes high temperature also makes the loss of this thing. So how the temperature variation in winter affect the crop part, that also we are going to discuss here. Then aviation sector, already there it is very well, because aviation is very prominent. Then flight diversion because of fog, etc. This is a very common thing. But now because of corona, of course, flights are less this year, so not there. But otherwise, always it diverse types. Also, how these sectors will be benefited for our warning and etc. That we will also discuss. Power sector. Power sector is another part, because of very high temperature summer consume lot of power. So power distribution, and it is a very challenging task. Like summer, winter also, because of very low temperature also power demand increases. So that's why how the POSOCO that they are working, and by taking our inputs from and providing the services to power sector, particularly with respect to dissemination of the power. And the cold and health. Health is an integral part, but it is very complex thing, of course. But cold, cold condition is very favorable. Respiratory disease are favorable. So and now the COVID situation is there. We believe that cold conditions, COVID will be more effective. So all these things, like winter weathers, are also going to affect all these sectors, and we will be discussing in our webinar all these aspects. And this is a news clip. Just I saw 25th November 2020. The cold, because of excessive cold, the Delhi power demand has increased. So this is just 2-3 days before news, 2 days news before. So that's why this is how this means temperature, cooling of temperature will increase the power demand. And this is a area where if you see, we can also do better services, and we can work together, and already we are working together. In fact, we have to improve, we have to understand their requirement, and accordingly we can provide the services in these sectors in a very effective manner through the collaboration. And agriculture, already I have discussed this one, and our colleagues experts also will cover this part, how the very cold temperature will affect the agriculture as also poultry and condition. And recently we have experimentally started the health service sector. So this minimum temperature, different window, and maximum temperature depending on the transmission favorable conditions, we are preparing this the guidance, 2-week guidance through our forecast model forecast product, and our CRS Pune office, IMD Pune, they prepare the advisory, and it is being disseminated to all the state government health workers, etc. And now we have to improve this thing, so that we have to work together with the health professional, those who are familiar with these things, so that we will have better understanding of vector-borne diseases, etc. Because and how it more prone during winter. That also we want to listen experts from those who will be there today to know better, and also to provide service in a more effective manner. So challenging area. So this is my last slides. So what we are going to discuss and how we can scope need better understanding of the physical processes behind winter weather system, because there is science part that there is WD occurring, fog, haze, cloud wave, cold wave. So these are there is science part involved, because sometimes fog is favorable. This is not a, though it is meteorological phenomena, but pollution is also involved in this thing. So we get haze. So there is of course we are doing some experiment, that winter fog experiment, but still there are a lot of understanding how the boundary layer physics there is playing a role. So that science part is also there. Then although through monitoring and better prediction, IMD is capable of doing this thing, model has improved, so we are providing good services, but still the impact studies of such events need to be carried out through collaborations. So that means the impact of all these events, so the monitoring and prediction, in addition that we have to go for impact of this study. One area not well understood is the morbidity and illness associated with cold wave. So cold wave very commonly whatever understood is there, but still there are some area where we have not clearly understood the morbidity of illness, and that's why there is also need to know each other. Then attempts should be made to for the real-time prediction of silent this disasters weather event, and suitable criteria need to be there. So for impact application, impact study, so that is our focusing. And since IMD through IMS, we are interested for providing expanding our services, and that's this workshop scope is that thing, and we are focusing only on winter weather, and also to understand the what are the requirement from the service sectors, so that we have to mutually collaborate with them, and IMS also will play a role for enhancing the services of IMD. Thank you very much. With this background, I just give an overview of what are the scope of this workshop, and we'll proceed for our next session.
Thank you, Dr. Patnaik. Actually, that schedule is very tight. You have already taken our 8 to 10 minutes more. So now the technical session first will be on winter weather systems and operations and NWP forecast. So in the schedule, the first lecture was by Dr. Professor A.P. Dimri, but now it will be, because Sachin Gude has to go early, so he will be delivering first lecture. So Dr. Sachin Gude is a senior scientist at IITM and an expert in aerosol studies, trace gas measurement, air quality research, etc. He has led a team for fog forecasting during winter in northern India, and today he will be presenting a talk on early warning system for air quality and fog. Dr. Gude, please.
Can you see the slide, sir?
Yeah, you can see the slide. Fine. So you can finish in 10 minutes, then maybe 2-3 minutes for questions.
Okay.
Okay.
Okay, sir. Thank you. Good afternoon, everyone, and thank you, Sahai sir and Patnaik sir, for giving this opportunity. So I will talk about MOS operational air quality and fog early warning system for Delhi. So I will start with early warning system for air quality, and if time permits, I will show you slides from fog forecasting system. So as we know, managing air quality in Delhi has become a complex issue, and as of now, we don't have any workable solution to manage this air quality. And therefore, an effective early warning system is necessary to warn the citizen of Delhi for any forthcoming air quality event. If you look at these two satellite pictures, we can see that air quality in Delhi not only is affected by the local sources, but during winter time, non-local sources also contribute significantly to the air quality in Delhi. These non-local sources are mainly from the biomass burning in the surrounding states of Delhi, dust emission, wind-blown dust, as well as the emissions from the surrounding states of Delhi region. So therefore, any air quality early warning system should have ability to process this kind of variability in sources quite effectively and reasonably. So therefore, we have developed an integrated air quality early warning system which takes into account not only the meteorological inputs, but it also takes the inputs from the air quality from various satellite platforms, from various local data sources, and deliver a forecast for next 72 hours. So we have currently 2 air quality early warning system running for Delhi, and which is operational since 2018. One is developed by IITM in collaboration with NCAR. This air quality system has 2 setup. One is at 10-kilometer regional air quality forecast, which gives a medium range air quality forecast. The same model is then downscaled to 400-meter resolution to provide high resolution forecast for NCR region 3 days in advance. So another system is developed by IMD. It is based on SILAM forecast in collaboration with Finnish Meteorological Institute. This model has 5-kilometer regional air quality forecasting setup, which provides forecast at 3 days in advance, and it has a street level forecasting system in future, which again give a street level air quality forecast 3 days in advance. So I will not go into the details of system architecture, but broadly the system has a chemical data assimilation system, which assimilate data from the various satellite platforms on aerosol optical depth. It also takes data from the surface monitoring networks. It also takes fire information from various fire satellites, which measures the fire counts. The model is driven by EDGAR emission inventory at 10-kilometer resolution, and for Delhi setup, it is driven by 400-meter emission inventory. The model has updated land use, land cover information for urban buildup, and this entire system is driven by analysis and forecast product produced by IMD, IITM, GFS, initial and boundary conditions at 10.5 kilometer grid resolution. So basically the system has two different setups. One is the 10-kilometer based regional air quality forecasting system, which is run at 10-kilometer resolution based on WAF. It takes meteorological driving from IITM, IMD, IITM GFS forecast. It takes data from 260 air quality monitoring stations located across India. It also takes data from Modi's aerosol optical depth, both at 9 UTC and one is at 9 UTC and one is at 130 UTC, and it takes fire count data. Once we run the setup, then we do the dynamical downscaling from 10-kilometer resolution to 2-kilometer resolution, which is an intermediate setup, and then from 2-kilometer resolution to 400-meter resolution. This 400-meter resolution setup is driven by our own emission inventory at 400-meter resolution developed by SERPER. The 400-meter resolution setup also takes data from local air quality monitoring stations in Delhi. So we take around 43 stations data into the model, and the model has updated land cover categories, as I said earlier. So when we run the forecast in the evening, the first step is that we assimilate all the fire information in the model, and here you can see that when we actually assimilate the fire data into the model, we can see a lot of increase in the PM 2.5 concentration, particularly over the region where we have lot of fire activity. And this fire information, you can see that once we do the fire assimilation, this kind of fire related PM 2.5 also we see the enhancement in the PM 2.5, and how this PM 2.5 emitted from the fire is propagated from towards the Delhi and northeastern region of India from the Punjab and Haryana sector. So we also did validation of this fire product. So what we did, we took all the stations which are available in the northwestern region of India, and we ran the setup with fire information and without fire information. So blue one is the without fire information simulations. Then red one is the simulation with fire information, and black one is the
email भर गया अभी.
So here you can see that as soon as you assimilate the fire data, you can see that model performs relatively very nice, and it captures all the enhancement in PM 2.5 concentration when you include the fire area. So we have also included the tagged tracers for the CO emission. So this tagged tracer is
Batra sir, please mute your mic. Those who are not talking, please mute their mic.
Okay, so in order to see the fire contribution in the Delhi's air quality, we have implemented tagged CO tracers. So CO tracers are nothing but it is a CO molecule which is emitted from the fire emissions occurring in the surrounding states of Delhi. And once we include these CO tracers, it travels along with the wind trajectory. And here you can see that how much CO is coming from the various fire zones of northwestern India and traveling towards Delhi. And the down figure shows that how much fire contribution we usually see during peak burning season. So you can see that on hourly scale, fire contribution can go up to 60 to 70% for CO, carbon monoxide. Once we do the fire data assimilation, then we do the aerosol optical data assimilation. So we assimilate both aqua and terra aerosol optical depth at 10 kilometer resolution. So here you can see that this particular figure shows WAF came without aerosol optical depth assimilation, and the right hand figure shows the WAF came with data assimilation, aerosol optical depth data assimilation. And here you can see that once you do the aerosol optical depth assimilation, you get lot of enhancement in the PM 2.5 concentration, and your actual forecast capture the enhancement in the PM 2.5 concentration. Again, below figure shows how much improvement we get when we do both fire data assimilation as well as satellite air AOD. So blue one is the observed, black one is again model without assimilation, and red one is the with assimilation. And you can see that once we do the satellite data assimilation, we get quite a bit enhancement in the PM 2.5 concentration, and forecast accuracy also improves. So this is the evaluation of our forecast product for last season. So right hand side figure shows the forecast for evaluation for daily mean, and left hand side shows the hourly evaluation. And you can see that overall the system is performing exceptionally well. The mean bias is around 13%, and you can see that model has a very good ability to capture the variation at on hourly scale. So you can see that model is able to capture sudden increase in PM 2.5 levels from about 100 microgram per meter cube to up to 500 microgram per meter cube. Again, it has a good capability of detecting sudden decrease in PM 2.5 concentration in same magnitude range. It also captures the slowly buildup of PM 2.5 in Delhi's environment, which is mostly driven by the western disturbances. So overall, this model has a very good forecasting skill and very useful for giving air quality forecast for Delhi. We also did a skill evaluation of our forecast for three different categories of air quality, because general public need information in terms of air quality index and how bad air is or how good air is. So we have, and the basic aim of this particular system was to improve the forecasting skill in the unhealthy, very unhealthy, and severe range of air quality.
Sachin,
So
may try to finish.
Okay. So 2 minutes.
Yeah, fine.
Okay. So the skill score shows that the model has a very good skill for capturing very unhealthy air quality category. It has also very good skill in capturing very unhealthy category, but model has still limited skill for severe air quality when air quality index is above 400 and above. So last year we could not perform surface data assimilation, and we thought these are the limitations why we are not able to capture the severe air quality events. So we did surface data assimilation, and now we are giving all the 43 station PM 2.5 data into the model every day at in the evening time. And we have also updated our land use land cover category with latest Sentinel-2 LULC maps. And here you can see how much changes we see if we go with the Modi's LULC category, or we replace urban classification with Sentinel-2 based data. And you can see that you get a change of the order of 1000 meter in the PBL height, and PBL height also governs your PM 2.5 concentration. And once we update the LULC in the model, we can see that our PM 2.5 concentration increases by 100 microgram per meter cube. And here you can see that once we do all these integration, then your model initial condition is improving tremendously, particularly for the severe events, which is highlighted here in the yellow circle. And I'll skip this slide. And now this is the latest forecast which is going on for this particular season, and you can see that how well is the forecast and how the forecast is capturing everything right from the start of the season and the current thing. And now here you can see that model has now able to capture the air quality index in severe and severe plus category. I'll also skip this slide. We are also giving 10 days outlook, and we have seen that this is very useful to see in future 10 days how will be the air quality and what kind of measures we should take. So this is an example of a Diwali emission. So usually you get very poor or severe air quality after Diwali. But this time we predicted that after Diwali, immediately after Diwali, they will have a severe event, but immediately within 10 to 15 hours, the air quality will improve tremendously. And the 10 days forecast was quite successful. You can see that on 15th November, the air quality went up to severe category, but immediately by evening 15th November, air quality was in moderate category. And this was very well captured by our medium range forecast. So we have public dissemination system. One is designed for general public and another one is designed for advanced user. General public can have information about what is current AQI and what will be the air quality forecast for next 72 hours in terms of air quality clock. And you also get the visibility information and spatial forecast of for entire northern region of India. And for advanced user, we give all kind of information right from the evaluation of day-to-day forecast and contribution of various sectors in the daily air quality. Thank you. So I will skip the Fox slide, sir. Thank you so much.
Okay, thank you. Thank you. So now, thank you, Sachin. Actually, there are not much questions in this. So we will, if anyone has question, he can write to Sachin directly for this. Now I will request, we will go to second speaker, Professor A.P. Dimri. And he is an expert in regional climate modeling, climate dynamics and variability, climate change. Earlier, he was scientist at DRDO before joining School of Environmental Sciences, JNU in 2008. He is a recognized personality for his research on winter weather and climate of Himalayas. With this brief introduction, I invite Professor Dimri to deliver a talk on winter weather systems and overview. Professor Dimri, please share your slides.
So can you see that?
Yeah. Yes, we can see. Thank you.
Yeah. Thank you, Sai sir. Thank you, Patnaik sir. I am just talking on demystifying WDs and its related links with various winter time phenomena. Of course, not limited to them when Dr. Patnaik requested me. So I'll touch upon on these issues, and Dr. Sachin has set a very good platform, and that is very concurrent issues. So these with brief outline, I'll be touching how the Western disturbances, which is quite well known by this time, and then how in the winter time in particular, it is interacting with various other winter weather systems. In particular, this is a very fundamental slide. All of us know that in case of summer monsoon March and winter monsoon March. However, one thing I definitely want to say that in the recent time, due to the climate impacts and climate change, these traverses of these two rain systems are moving towards not the conventional march, and hence there is a changes in their impacts on other forces. So in case of Western disturbances, in particular, due to the global warming and climate change, subtropical westerly jet has a very severe north-south fluctuations. By virtue of that, the embedded Western disturbances in the subtropical westerly jet also have a very different kind of connotation and behavior over the Himalayan region, and that interaction orographic forcing in the modeling setup, we have done that. So if you look at these cold weather system, which Dr. Patnaik has looked into, these are the mid-latitude frontal system, well known but not extratropical cyclone, because mid-tropospheric low is adjusted with the extratropical cyclone, hence it's redefined that as a Western disturbance in the conventional way. which we are talking. However, the precipitation and dynamics which are associated with this Indian continent, Indian subcontinent, we have seen that there are various issues related with the precipitation, which is associated with WDs, influences, the hydrological budget. There is a long debate is going on with the glacier forcings. There is a debate going on the permafrost, and there is a debate also is going on the various other water security linked to this, as the Himalaya is considered as a water storage, water tower. Some people try to refer. In addition to that, when western disturbances, when they are propagating in some time in the summer, they have a very distinct interaction with the Indian summer monsoon. Also, there are recent cases where when WDs have come down south over the Indian subcontinent, and during this summertime, they have interaction in the Indian summer monsoon systems. If you look the western disturbances, their vertical structure, if you look at this, I am just showing one of the figures. Based on that, it says that it shifts towards westerly side when we are going to the earlier stage of development of WDs. This vertical head of the WD is tilted towards the Afghanistan northwest side, and when it is over Indian regions, its toe is over the Indian region. However, with the propagation of the WD is more influenced by the head, and it moves towards the eastern side. So conventionally, the WDs are higher elevation system, higher precipitation system, not as the case in the monsoon, which is the lower elevation system. And then interaction with the existing monsoonal and existing Himalayan topography is very distinct, and northerly shift of the vertical dimension is seen during evolution of the WD. And this suggests in a way that there is a pressure levels during a WD has a northwesterly tilt in the early days of WD, which happens in due course of time, which becomes a northeastern. Of course, there is a lot of variability in the associated precipitation as far as WD is concerned. I am not going in the detail and debate on the liquid precipitation and water precipitation. However, the life cycle of origin, evolution, and propagation in due course of time is understood of the WDs. If you look at that in the other aspect of the interaction of WD, if we say so, we find that they are defined as the two synoptic characteristic, which is very distinct for that. Why I'm setting this, because this what is yet to be known, that how these upper tropospheric depression in the subtropical westerly jet are figuring in the models which are not very keenly captured, which is the hypothesis or the theory which is proposed long back by 1977. And this tilt of low pressure system in the vertical axis definitely can be attributed to the evolution of WD from western side of India. This emphasis of the westward tilt primarily is because of the mid-tropospheric low, which is situated over the Gujarat region, and this leads to a wave-like disturbance or distribution of this interaction with the orography. So there is a kind of a cascading movement happening, which has a certain oscillation periodicity when it moves in the large scale westerlies and embedded with that. And then there is a number of WDs which travel together in large scale westerlies. Interestingly, the orographic lifting makes it more complex to understand once there is an interaction along the steep relief of the southern front of the Himalayas, and that leads to the sub-regional climate over the central Himalaya, western and eastern Himalayan region. If you look at the paleoclimatic point of view also, then these WDs have a different distinction, where there is a kind of, even we do not know how far the WD goes down. There is no set threshold how far the moisture available from western disturbance come in the southern front, and how far the Indian summer monsoon goes northward. So there is a kind of a imaginary boundaries people have considered somewhere in the central Himalaya Chandrabhaga basin, where they say that there's a likely that the frontal, quasi-frontal distribution between Indian summer monsoon moisture and winter monsoon moisture, leading to the different kind of rainfall over these regions. If you look at the intensification of the circulation associated with the WD, topography has a very distinct role over this, and the vertical cross section which I am showing here, which tells that how topography kind of lifts it for increased precipitation, and we found that the most of the western disturbances which are yielding the precipitation, they are limiting precipitation roughly 3,000 to 3,000 meter to 3,500 meter of elevation in the southern front of Himalayas. They don't go beyond that in general. In sense, I'm not considering some worst cases where there is a very higher cape is associated with the WD, and this distribution of vorticity and that particular case of WD in 2002 shows that orographic forcing along with the WD plays a very distinct role as far as the precipitation modulation is concerned, precipitation quantity is concerned. And very recently we tried to look at for a WD index in the context of if there can be a possibility of forecasting in purpose of the model. What we try to do it knowing that the head of the WD is tilted towards northwestern side and toe of the WD is resting over the Indian plain at the initial state. If WD index can have certain kind of indication, if we are trying to look at in the mathematical model utilization, and then this value of 850 hectopascal and 200 hectopascal we have calculated and kind of constructed a standardized WD index. It's a very primitive study as far as the WD index is concerned. However, we find that WD index it increases with the number of WDs in almost except here whenever there is a more number of WDs. We found that this is primarily the index based on their intensity of western disturbances and then geopotential height. And we also have seen that how the 500 hectopascal wind is positively correlated with WD index, primarily for the western side of Himalayan ranges, which are the Hindu Kush range or Suleiman ranges, which is the first entry point of the WD where it hits the orography from when it travels from the west side over Indian region. And we found that when it rests over the region, a certain kind of negative correlation is found, and hence these two regions where it hits first, the mass of divergence of mass from the rest of the region has seen, and this leads to the colder temperature in that side. However, in the northern part of India, we have observation also that warmer, because of WD, there is a warming temperature has been comparatively seen, and then this is suggests that cold air incursion towards India takes place during the passage of WD. And there is a mean sea level pressure also, because there is incursion of moisture from the Arabian Sea is also added up on this distribution.
Professor, do you need 2 minutes more?
Yes, sir. I'll do faster. So we also have seen that there is a low, though winter time, the hailstone is very not very conventional phenomena, and hence when we are talking of the upper level instability and the baroclinic instability, we found that WD has an enhancement of the winter time hailstones over Delhi. There are observations when the few times hailstone has occurred, and the conjugate effect brings the instability which develops multiple cloud cells and conducive for hailstone. There is a WD and monsoon interactions also happens where there is a propagation of monsoon trough has been noticed. This hypothesis was provided by Pisarati, and we tried to explain this pulsatory extension of monsoon system in summertime. Whenever there is a north, we have a WD coming in the monsoon time, and it leads to an occluded discontinuity or front over the region. It has an intra-seasonal oscillation also of 7 to 25 days in the winter precipitation time. And in changing climate, if you look at that, Madura et al. Has shown that how the changes in meridional temperature gradient index, which it shows that the baroclinic eddy activity happens over these regions. And these, based on this index, they have tried to let out that enhanced baroclinity favors the enhanced activity of WDs. In case of fog, maybe I'll only touch upon, Sachin is more expert on this. We found that 1997 onwards, there is a certain increase in the percentage days of frequency in winter time has taken place based on this 10 station and observation. Maybe Sachin will be able to give more enhancement, more knowledge on this. So I'm limiting it here. It's not that I have taken only few of the references and a few of the cases, but that is very peculiar that meteorological impedance particularly need to be looked into as far as the winter fog is concerned. I am not talking about the pollution, but winter fog is concerned. Thank you, Sahai sir.
Yeah, thank you, Professor Dimri, for taking exact times and good. So if there are any questions, please ask Professor Dimri through email because we don't have much time. So now the third talk will be by Dr. Raghavendra Asrit, who is a senior scientist at National Center for Medium Range Weather Forecasting. And his area expertise includes ensemble prediction, high impact weather events, spatial verification methods for dynamical forecasts, etc. And I invite with this Dr. Asri to deliver a talk on model forecast products from NCMRWF for various winter weather systems. So, Professor Dr. Asri, please.
Thank you, Dr. Sahai. Can you hear my voice?
Yeah, I can hear, but you are not sharing.
My screen is shared. Not yet.
I am not able to see. Maybe.
I'm sharing the screen now.
No, we can't see still. Yeah, it's there.
Yeah, now it is okay. Fine.
Okay, now I will make it full screen.
Yeah.
Is it okay?
Yeah. Yes. Okay, fine.
Okay, thank you. I thank IMS organizers for giving this opportunity. We are working very closely with India Met Department, and we are happy to take their feedback and modify and improve our products accordingly. We do it for the tropical cyclones, also for the winter and during the monsoons, heavy rains, and all the severe weather events. I'll quickly present before all the colleagues and audience from different agencies about the NCMRW forecast products during winter season of 2021. This is the overall infrastructure modeling facility that is we are working with. We have high resolution global modeling facilities, regional modeling facility at 4-kilometer resolution, if I can point out using my cursor. And regional models are like limited to the smaller domain. Global models are used for capturing the large scale variability, large scale synoptic systems, and other such influencing weather systems. And I will take a quick walk through all the forecast products that are used for with specific focus on the winter related weather issues. And here I have listed out various modeling systems that are engaged in producing the forecast. We have a global modeling system which runs twice daily, which is listed on the top, once based on 0 UTC and once based on 12 UTC, and it generates forecast products at 12-kilometer resolution. Similarly, at same resolution, we have an ensemble system with 12-kilometer resolution and 11 members as the perturbed members, and combining the 11 members from 0 UTC and 12 UTC both, we generate members from both cycles. We generate forecast products of 23 ensemble members. And similarly, we have high resolution regional model of 4 kilometers, which also generates forecast products out to up to day 3, and high resolution 4-kilometer regional ensemble also, which is a new product, and we have started using it just 1 week ago. This also generates forecasts out to 3 days. Additionally, we have experimental setups, configurations. A little bit of the results also will be shown in the presentations. Now, essentially, with the focus on winter, these are some of the parameters that we produce here based on the deterministic system. Spatial plots of forecasts of visibility, relative humidity, ventilation index, these are generated, and location specific time series are produced for visibility, relative humidity, temperature, PBL height, wind speed at hourly interval. These are produced up to day 3, and generally these are generated for Amritsar, Delhi, Lucknow, and Varanasi, and these are shared to India Met Department. Good thing is, like, observations are also available for these locations. Forecasts can be generated for all many locations since we have very high resolution model. But we are trying to focus to start with because these are the locations where we have observations, and we have a chance to do some verification. And similarly, from the high resolution deterministic model also, we have all these parameters, and we use the 1.5 kilometer and 330 meter models for experimental exercise to see how forecast of visibility and near surface fog and the PBL height and how it can be improved. So some of the experiments are also going on using the regional model. And we have probabilistic forecasts of visibility generated using the global and regional ensemble systems up to day 3. So just to give a glimpse of how is the type of quality of our forecast, and I have just tried to provide a verification here. What is shown in the top left is the forecast verification for 28th of December. So we know that at the end of like the year, we had very severe cold wave condition, and that is the top left panel, which shows the observations where temperatures are below 4 degrees, spanning a large part of northern India, and that is nicely reflected in day 1, day 2, and day 3 forecast. And subsequently, of course, there is some indication of the signature, all those locations are not very nicely matching. So by and large, we can say that the modeling system was able to capture the cold spell very well. Similarly, for 29th is shown in the bottom panel to show the stagnant nature of that particular spell, which lasted for 3 days. This is up until the 1st of January, we still see this one. I'll quickly move through and see, come to the current year and event. This is the predicted visibility that is based on 20th of November. So although the northern part of India is still like much clear and poor visibility events have not yet started, and very soon they may begin. And what is shown here is, as an example, just I picked up the plot directly from the website, and it shows like a mist kind of a thing over large part of India. And for 4 locations here, I have shown the top left is for Amritsar, right is for Delhi, Lucknow, and Varanasi. These are the regions for which top panels show visibility. Since presently it is still clear, like we don't really see poor visibility, everything is above 1000 meters. And time series of temperature and humidity are also shown. Boundary layer height is also shown here, and 10 meter wind speed. These are some of the products, and based on the ensemble system, we can also generate the probabilistic forecasts of visibility, which is shown here. Day 1 and day 2 forecast, left side is for day 1 and right side is for day 2 forecast based on 20th. So probability of visibility less than 1000 is shown only mainly over some pockets here, and some isolated pockets show very high probability close to the coast. That is what is seen in but anything like probability poorer than less than 500 and 200, it's still not much to be seen here. Although some isolated locations like near Bangalore, we can still see like there is high probability of visibility being less than 500 and 200 meters. That was seen 2 days ago. Of course, we have to cross check and verify these one. I'm just showing it. These are types of products. And this is the new one we have started generating based on 4 kilometer ensemble system. This is the visibility again. Ensemble mean visibility is shown in the top left, and forecast probabilities are shown in the 3 panels. So as the season advances, it will be interesting to see how effectively we will be able to improve upon the global model forecast probabilities of poor visibility. This we will have a chance to see. Further going ahead, we know that for winter temperature forecasts, it's very important, and our operational products are bias corrected. This is just to show how the bottom middle panel shows zero bias, like nearly zero bias after bias correction exercise is carried out. This bias correction is essentially for one whole month. And based on the bias corrected forecast products, we generate the temperature tendencies also. This shows the temperature tendency based on 27th of November. We have generated the temperature tendencies for the next 8 days. and we can clearly see that next 3 days, 29, 30, and we can clearly see decreasing temperature and subsequently slightly increasing tendency in the temperatures. That's what we see over the northwest part of India. This is the type of product which is generated, and this is based on the bias corrected product. And similarly, bias corrected maximum and minimum temperatures are also available on the website, and also they're available for the forecasters to use. And based on 27th, like we have a day 1 forecast which is valid for 28th, day 3 forecast and day 5 forecast, and clearly we see like temperature in the northwestern part is dropping. In day 1 it is just around 10 or 12 degrees, and by day 5 the temperature is decreasing to just around 8 degrees or so. So we expect to see, as per this bias corrected forecast, we expect to see drop in temperature in the next 5 days in the minimum temperature. Not much change is seen in the maximum temperature. That is what is shown in the bottom. And based on the ensemble products, we also have constructed the for capturing the extreme cold conditions. We are trying to express our forecast in terms of difference in terms of the percentiles. So lowest 10th percentile is taken as threshold, and to see if at all any cold spell is predicted, how severe it could be. So such products are very useful. And similarly, percentile based extreme weather indices are also available, and I'll quickly move on further. What is important is use of high resolution models for experimentation. Our colleague are carrying out a lot of experiments using 1.5 kilometer and 330 meter models. Interesting thing is these models make use of the inventories, that is emission inventories, that are available from India. And we can quickly check and how it makes an impact in terms of using the fixed constant emission inventories and actual measured emission inventories. That is what is also discussed here. And experiments also show how like this biomass emissions from global fire assimilation system, this GFAS system, converts the observations from MODIS satellites into fire radiative power, and that is a very important ingredient that goes on into enhancing the model's capability to assess and assimilate the impacts of stubble burning. And that actually has an impact in terms of reducing the visibility through black carbon concentration.
Ashrit,
so
please.
yeah
Yeah, take another 1-2 minutes and finish.
Yeah. I'm almost I'm coming to the end. This is the highlight for this particular season. So what we clearly see is bottom left panel shows the model estimations and simulations, wherein your visibility is not. This is a case. This is a particular case from 24th of December. Predicted visibility is like it's not at all. It's very high visibility is seen here, but with inclusion of inventory emissions, and we can see drop in the visibility, and that is actually matching with the CMIP5 estimations also. And the same thing is estimated like shown in terms of time series within a particular day for different for the 3 experiments, like how visibility is affected, temperature and relative humidity are affected. And similarly here we can see, as we move from right panel to left panel, with CMIP5 concentrations, we do not have accurate estimation of aerosol concentration. It's very poor in the 330 meter model. And with the inclusion of Edgar coefficients and constants, like we have a slight improvement in terms of aerosol concentrations after a simulation experiment with including the IITM measurements. We have a nice well evolved, developed, strong concentrations typical of urbanization that is associated with Delhi is nicely simulated. And similarly, we can see the impact in terms of the time series over a desired location. So similar experiments are also showing the impact of during and after the stubble burning, and that is also seen in to change in terms of the wind conditions I'll quickly go ahead. I'll not explain much into all these, and it is also seen not just at one location but 3 or 4 different locations over Delhi. And yeah, that's all. Like, this is typically to show over Bulandshahr how the bottom panel describes the drop in visibility, and subsequently with winds the increase in visibility is also estimated in the model. This is similarly, we have an online real-time verification also associated with the event, as the data is also coming in the models. And further, the future steps is there are a lot of efforts to include the urbanization tiles, urbanization, urban heat, urban heat island index, and other such parameters assessed by the ISRO satellite-based data sets. And this study is still going on. So I'd like to just close with this, and thanks. I'll be happy to take up few questions at the end of.
Thank you,
session.
Ashwin. There is no time, so maybe they will ask you through email. So thank you for this. Now the last speaker, not last and not least, but Dr. MS Sekhar. And he is a very senior scientist at Snow and Avalanche Studies Establishment, and contributed a lot in monitoring, understanding, and forecasting also severe weather systems in Himalayas. So today he will be delivering his talk on snow avalanche monitoring and warning services. So with this, I invite Dr. Sekhar to deliver the talk. Please, Dr. Sekhar, share your slides.
Am I audible?
Yes, yes, you are ready.
मेरा दिख रहा है presentation?
हाँ, सब दिख रहा है, सब दिख रहा है.
Okay, thank you. Good afternoon, everybody. So at the outset, I would like to thank Indian Meteorological Society for giving me a chance to deliver a talk in front of this Augustus gathering through the video conferencing. Before starting, I just want to give a very small information that the name of our lab has been changed to DGRE. It's Defense Geoinformatics Research Establishment, and it has been done by merging 2 labs, Defense Terrain Research Laboratory at Delhi, and second is our SASE, Snow and Avalanche Study Establishment. And now the new name is DGRE, and it has already been effected from 15th November 2020. So hence, any correspondence now should be done in the name of DGRE Chandigarh. So this is a small information to all of you. But the address will be same, of course. So I will be starting my presentation. I will be talking on snow avalanches monitoring and services, and I will try to touch upon the operational part of the presentation rather than going much into the technical, mathematical, and equational part. As you all know that during winter, many parts of India and Himalaya get affected due to the severe cold weather events, the western disturbance. And these western disturbances give copious amount of snow and rain over Himalayan region. And this heavy snowfall and gale winds associated with these WDs cause snow avalanches and road blockages in the snowbound areas of Himalayan mountains. The Himalayas are considered to experience the most devastating avalanches during winter, as all you know. Now coming to the avalanche, an avalanche can be defined as a sudden downward motion of snow mass from the mountains towards the ground. And during the course of its journey, it may bring rocks, soil, ice, trees, etc. and exerts pressure up to 50 ton per meter square. I think which is a great enough to damage several buildings or vehicles which comes in the path of the avalanche. And it may range from few meters to few kilometers in size also. Now, this slide shows the implications caused due to the avalanches in the Indian Himalaya region. It affects the pedestrian movement and cuts up villages for many days, erodes soil cover and affects vehicular movement, disrupt the hill development. It badly affects military operations, their movements and day-to-day operational activities. An avalanche can damage hill roads and dams, destroys forests and affects the winter sports and tourism. Communication is also badly affected by it. And above all, it affects psyche of the person who got badly affected by the consequences of the avalanche. Now, in this slide, it can show that the maximum number of accidents in Indian Himalayas took place during the event of snowfall or when the snowfall is continuing. The second most dangerous weather situation is the clear day just after the cessation of storm. Now, every year, a lot of avalanche incidents, accidents, and casualties of army, paramilitary forces, and civilians takes place in Indian Himalayas, which causes a huge loss of lives and property. Since mountain weather is one of the most important parameters for the avalanche to occur, hence there has always been a requirement of both mountain weather and avalanche forecast for the following personnel as well as agencies. The list of the agencies which requires the avalanche forecast has been listed here. You can see easily in the slides. The area of responsibility of present DGRE, former SASE, encompasses Indian part of Western and Central Himalaya and the Sikkim in the Northeast Himalaya. And we have mapped avalanche sites along various routes, road access in avalanche-prone areas where mostly army and civilian movement takes place. And it has been done, this mapping and all these things has been routinely done by ground recce, aerial recce, and by using remote sensing and GIS technology. Since snow meteorological parameters from avalanche-prone areas are used in predictions models to assess the avalanche danger, DGRE has established a vast network of observatories, surface observatories, and automatic weather stations in these regions at various elevations in Indian Himalaya. Now, regular SNOMED data is being collected daily from this observatories network and sent to our DGRE Chandigarh through our mountain meteorological centers, which are commonly known as MMCs, and RDC Manali. Now the headquarters Manali is known as RTC Manali, Research and Development Center Manali. Here we generate both mountain weather and avalanche forecast, and finally the forecast is disseminated to the users through the same mountain meteorological centers as well as directly from Chandigarh. SASE started mountain weather forecast independently by the mid of 90s. Present day, SASE, DGRE provides mesoscale mountain weather forecast for entire western central Himalaya as well as Sikkim in northwest 6 days in advance, and it is being updated every 24 hours, every day. The final mountain weather forecast generated every day is provided to the users in Union Territory of Jammu and Kashmir, Union Territory of Ladakh, Himachal Pradesh, Uttarakhand, and Sikkim through proper channel. The forecast is also generated to the National Disaster Management Authority, NDMA. Now coming to the avalanche forecast, we use both active and passive methods for forecasting and managing the avalanche in snowbound avalanche-prone areas. The active methods are controls release, structural control, afforestation, and the passive methods are avalanche forecasting and avalanche awareness. Avalanche awareness is nothing but the training to the users. Now we assess the avalanche danger in the active snow avalanche zones daily using various avalanche prediction models and issue avalanche danger warning to these areas. Among the various methods of avalanche hazard mitigation, the direct or passive methods, also the direct methods is also known as passive methods, is the avalanche forecast or avalanche prediction. Avalanche forecasting is the most economically viable, effective, and practically suitable methods, as it can be applied to a larger area and requires much lesser investments as compared to direct or active methods. Avalanche forecasting may be practiced at various spatial scale levels as per the requirement of users. Mountain weather prediction and prediction of snow amount is an integral part of the avalanche forecasting. So, with the passage of time, with the advancement in computing technologies and all, and decision-making algorithms, this avalanche forecasting has benefited a lot. Now, avalanche monitoring. It is a very important procedure in avalanche forecasting method. Regular avalanche monitoring is required for updating various avalanche models and also for issuing accurate avalanche forecast. This is achieved regularly by collecting avalanche occurrences or incidents from the users on regular basis. Since avalanche incidents generally occur in high altitude, snowbound, inaccessible snowbound areas, these information are generally collected by carrying out ground reconnaissance and aerial reconnaissance immediately after the cessation of the, stopping of the snowstorms, and also by remote sensing tools. Now, coming to the slides, this is the dissemination part. We generate avalanche forecast every day for next 24 hours during winter. Winter means from starting from November 1 to 30th April every year. And the forecast is sent to various users through different channel. We send our forecast to Army through their Army Wide Area Network, generally known as AWAN. And we send our forecast to our cluster Director General, Chairman DRDO, and Raksha Mantri during the whole winter. We send our forecast to paramilitary forces and also to the civilians, as I said, NDMA, SDMA, and PTI. Now, along with Army and other paramilitary forces, just I told you, the forecast is being sent to NDMA New Delhi and as well as SDMA Himachal Pradesh as the national agency share the knowledge, experience, and expertise of avalanche forecast with the civil society. Now, we would be able to locate where the avalanche can occur spatially and temporally. Also, we can predict the avalanche based on the weather condition. During winter, we keep a watch on the possible occurrences of the avalanches and do alert the army as well as the civil authorities so that the common man is not affected by the event, particularly those who are going to high altitude areas for adventures, sports, and other privileges. Now, civilian people who are unaware of the snowbound areas or the users as a part of their strategic movements get caught by the avalanches. So DGRE have the ability to locate people buried under the avalanches. As a part of passive mitigation method, we impart training to the army on step movement, avalanche prone areas, data collection, regular data collection. Recently, we have also started imparting training to the quick response teams of Himachal Pradesh and planning more this type of training programs for the civilians living the snowbound avalanche prone areas in the Indian Himalayas. We have a lot of avalanche awareness materials and products in the form of books, brochures, posters, CDs, and DVDs for the users residing in. Yeah. Okay. Just I think 2-3 slides or in avalanche prone areas. Okay, what I was telling since the infrastructure, communication, power, transportation, and housing are really affected by as a method to protect these buildings, highways, power transmission, towers, and other important structures. As a part of avalanche monitoring and mitigation methods, we have designed, developed, and installed different avalanche control structures for different avalanche zones so that their speed, volume, and with the tolerable levels. This slide, you can see the control structures that has been installed in the holy Badrinath Dham. And numerous solutions and suggestions have been provided to various national and states agencies on different structures for protecting and mitigating from avalanches. Now we have a very good research desk in Himachal Pradesh for carrying out snow avalanche dynamic experiments as per the international standards, a cold lab facility to carry out snow sample test, or virtual reality centers as a part of training programs to the users. Finally, I would like to say that in due course, DGRE or SASE has emerged as a frontier research center in cold region science and engineering for saving precious lives in snowbound mountainous regions of India and Himalaya. DGRE is actively engaged in basic and applied research in area of cold region science since then, and is striving hard to reduce the suffering of Indian troops and civilians in terms of safe mobility in harsh extreme climatic conditions of Indian Himalayas. the activities of TGRE have increased manyfold, and it has taken up state-of-the-art projects of national importance and have emerged as one of the premier establishment of DRDO. Thank you very much.
Yeah, thank you, Sudhanshu. Actually, I thank all the four speakers for their nice presentation and keeping the time. So now the first session ends and the second session will start, and I will hand over the podium to Professor S.K. Das, the chairman of the second session. Please, Professor Das.
Yeah, thank you, Dr. Shah. It's not very late, it's 5 minutes. He could finish on time by not allowing anybody to ask any questions. And I can see also on this chat that Dr. Rana, the first speaker, is already ready and he wants to complete within 10, 12 minutes. I'm very happy to get his message. I just want to take 1 minute by saying that this is a very good initiative by IMS, and first session was a success, and in the second section there are 5 talks on 5 different aspects. I will just want to introduce all the speakers are very distinguished. First one is on the agriculture field, Dr. Rana from Palanpur, and second one will be on human health, very distinguished scientist Sanjeev Kumar, who was the director of IIHMR and very good experience in health and climate change. And then we'll be seeing from the IGI Airport, New Delhi, on aviation aspect. And then we'll have Dr. Alok Kumar from Poshoko on power sector, and Wing Commander Satyam Kuswa, that is MRT and H regarding the transport. I request all the speakers to stick to 8 minutes. I will 8 minutes with 10 minutes actually, but I will give a signal. I'll tell before 2 minutes so that you can complete. And please remember that I know that there is a time constraint. In IMS, we'll discuss in future how to give some more time for discussion. I think without discussion, this type of webinars don't have much meaning. So, but for the today thing, I request all these 5 speakers to leave some time so that at least a couple of questions can come up on the chat. And I also request all the participants to put their questions on the chat so that I will try to pick up at least 1 or 2 questions. Thank you very much. Now I request Dr. Ranveer Singh Rana from to speak on the agriculture impact, climate change and agriculture, especially winter weather related to agriculture. Dr. Rana, please.
Thank you, sir. Hello, am I audible, sir? Am I audible?
Yes, please go ahead, Dr. Rana.
Okay. Thank you very much, sir. So very good evening and my kind regards to all the dignitaries, Honorable Director General DDGM, dignitaries, Dr. Das. My topic is on winter weather system and its implication in agriculture and livestock sector, and in relation to the these are some of the challenges why we are discussing the winter season, because these Rabi crops, they contribute around 40% toward the growth GDP. So that is why they are very important. And these are some of the constraints which are experienced in the cold weather in Himachal Pradesh, specifically in context to the Himachal Pradesh. And these are the food challenges that we have to increase the food productions by managing the weather data. And these are some of the facts just to highlight in the northwestern Himalayas, because we are facing the winter season, severe winter season in this Himalayan region. These are some of the slides which are showing that there is increase in the temperature, decrease in the rainfall, and these are some of the farmer perceptions that is the primary source of data that is showing. So the winter weather system, it is the coldest season of the year, and it plays a very important role because all the agricultural activities, they are impacted because of this winter weather system. And there are sometimes there are the injuries because of the winter weather. Adverse weather conditions can cause production losses, even sometimes experience the critical stages, even during the growth stages, it influences the crop growth also. So the major challenges are the water scarcity during the winter season, that is the Rabi crop season, and then the warmer winters, that is toward the end of the season. We face the terminal heat, and that reduces around 30% of the total yield of the wheat crop in these regions. Then the untimely snow, it is also problematic for the nomadic graziers, because lot of nomads, they comes from the high hills to the lower hills, and if there is early snow, if there is a delay in the snowfall, then they cause loss to them. So more winter rains sometimes, and the less snow, it is also a problematic in case of the Himalayan glaciers, and in case of the stone fruits also. The low temperature, frost, hailstorm specifically occur during the March and April, that is toward the end season of this Rabi season crops. And then natural calamity already mentioned by our previous speakers. Then the animal health and productivity, fodder scarcity is another reason, and there is a diseases and livestock in this animal sectors and in the crop sectors. So these are some of the issues which are related to the agricultural crops, because these need to be addressed. And this is the one case study, and it happens in all over the northern western India, that the winter season during this March, April, and up to this March, April, and May, it is a deficit period, and similarly during the October to December, it is a deficit period. Only the January and February, sometimes we get the good rains, and it is good for the crop health. In case of the, if we talk about the implications in the cereal crops, vegetable crops, and the horticulture crops, they experience the snow, frost damage, and low temperature injuries, and that generally those injuries that lead to the bacterial diseases. And even if we talk about the winter season favors the winter crops also, because these crops, they are the suitable for this reason. And there are some of the other issues, like in the early season, early onset of the winters, then there is a seed germination, development, they are all slowed down, and which cause relatively, which cause sometimes rotting also, and the dumping of disease is one of the major reason during the crop season. Because in the Rabi season, the major constraint is the capturing of the sowing window, that is during the October to December, capturing the soil moisture. And this is very important. Sowing of these crops, it should be preferably between 16 to 22 degrees of the soil temperature, and delayed generally cause these type of the injuries to the crop plants. These are some of the symptoms of the crops, some of the reduced plant growth, sometimes deaths also. There are other symptoms they are developed. This I have prepared with the elevations, crop distribution, and climate. If we increase, if we go on to the higher altitude areas, where we get the cold temperature also. So these are the different crops which are distributed over the region based on the element, and based on the elevations and the crop, and based on the climatic conditions also. And these are very important for these winter season crops. So diseases, these are the few diseases of the winter season crops, in case of the wheat, gram, sarso, and linseed. So all these diseases, they are expected, and the majority of the stations, they have prepared the climatic metrics also, when to this forecast these diseases based on the weather forecast available from the IMD. It is one of the flagship program of the IMD operational throughout the. And then in case of the peas and potatoes, even the potato crop, it is having in the lower region, that is adjoining area of Himachal Pradesh, Punjab, and Haryana, they face the late blight of potato, but that happens during the March and April also. So these are some of the conditions for the late blight of this potato crop. These are some of the Escovita blight of the pea crop also, which damages the crop during the winter season. And these are the diseases which comes during the winter season. These are some of the insects and pests I have mentioned over here. Aphids, wheat aphids is a new aphid which is appearing in the middle latitude also, between the more than 1,000 meter height also. And these are some of the other diseases but these diseases, they mainly do not come during the October to December, but they come after the February, as soon as the temperatures start rising above. And these are some of the insects. I have given the photographs also, bee termites also in chickpea. This is a pod borer also in mustard aphid, the mustard sawfly, diamondback moth. These are some of the diseases. And these diseases, the majority of the agricultural domain experts, they have made a very regressive equations for predicting these weather. And when we integrate the forecast of these medium range weather forecast using with these predictive models, we can manage these crops very well. So in case of this, the weeds are very important aspects. So these are component technology of the crops, and these are some of the weeds which come across during this winter season. And if we talk about the crop operations, then the winter seasons generally the sowing should be done between 16 to 22 degrees centigrade. But in case of this, forecast event, if 12 to 30 millimeter of the rainfall per day event we receive, then the soils of these regions they are likely to be in the conditions like field capacity, and they are suitable for sowing of the crops. So this way we have to find out all these values, whether in some of the crops it is 12 centimeter, in some of the crop it is 20 centimeters. So depending upon the type of the soils, even the use of this crop simulations model for the sowing window, modeling the sowing window is also required to be integrated in this during this winter season. Weed management advisories, low temperature period during December, January, they are beneficial. But if the frost occurs during this period, then frost management has to be done. There are all these agronomic recommended practices are available for these things. So the vegetable crops, they are more sensitive to the low temperature, and then agronomic manipulations are required. And during the Rabi season crop, as we face that there is a water scarcity during this period, so the irrigation should be based on the real-time weather data, so that we can reduce the number of irrigation instead of going for the stage of the crop and time period of the irrigations interval. Even sometimes we apply this fertilizer application to these winter season crops. So at the 60 to 70% of the saturated moisture, they should be applied, and this 60 to 70% of the saturated soil moisture, it is attained when we get 12 to 30 millimeter of the rainfall events. In case of these horticultural crops,
2 minutes, please.
Okay, we have the three types of this fruits, that is temperate, subtropical, and subtropical. So temperate fruits are already benefited because of this winter season, because they are suitable for this. These are some of the photographs where we do the winter pruning also, and other practices the farmers they do. And these are some of the photographs. Even the floriculture, it is also impacted because of this. We have the advisories for this. And if we talk about the livestock sectors, so livestock is very important, and there are many diseases which come during the winter season, and they can be managed using these practices which are recommended by these. These are during in GKMS. If we see the temperature, if the animals they are in discomfort, then we can advise them for the practices which are suitable for increasing the yield of the. These are some of the implications are the poultry crop, house management, brooding management, litter management. These are non-monetary inputs which can be managed, and they can increase the yield. Similarly, for the fishery sector, because the fish they do not eat anything during the winter season, even sometimes they stop eating anything. So we can reduce the feed intake of these, and this is with respect to the apiculture also, because apiculture is they are the pollinators and they are very important. And similarly, we have covered this mushroom cultivation. In these mushroom cultivation, this is done under the controlled conditions, but the outside weather also impacted this thing. The sake mushroom is one of the new introductions to this. And then one more thing I would like to mention here, that micro-based approach should be followed, and this advisory generation for these things. And if we talk about the core damages, there are many biostimulants which are available, and which should be included in the agro advisory. But this component has still lacking, and but it should be included. It should be integrated in the future. There are some of the water saving techniques which should be advised in the initial, and there are some of the other geospatial products we should use for augmenting the agro advisory services. And finally, we say the in hill region, protected agriculture is one of the most important adaptation strategy to combat with the extreme weather condition. And these are some of the conclusions that the winter season weather system they affects the cereal crop less than the vegetable crop, and the weather agro advisory based on the medium range weather forecasting. It is beneficial and it can helpful to the farmers. Thank you very much, sir.
Thank you, Dr. Rana. I don't see any question on the chat box, but I have my own question. That is, in winter in India has
Yes, sir.
different type of special impact. That means in the Himalayan region, IHR is very much different from the southern part. So, is there any specific crop which is being affected in the winter. Apart from apple, I think we know in common way we know certain fruits, etc. But any other crop which is very different from the very much affected by the severe winter in the Himalayan region rather than in the southern part.
Sir, actually, this apple crop is the killing is one of the requirements. But extreme weather, that is temperature less than 1 degree, it impacts this crop also. But in the majority of the cases, whether it is apple crop or other stone fruits, they are beneficial because of this, because they are grown up to 2,500 to 2,800 meter height in tall and sticky. Beyond that region where the snow clad is there, these crops they are not grown in those regions. So there is no any crop which is highly affected because of this extreme winter.
Okay. Thank you very much, Dr. Rana. Thank you very much.
Thank you.
Now I request Dr. Sanjeev Kumar for his talk on the human health aspect. Dr. Kumar, please.
Thank you, sir. Can you hear me, sir?
Yes.
Okay. Do you see my slides as well?
Yes. I can see very well.
Thank you, sir. Thank you. Thank you, Professor S.K. Dash, for introducing me earlier, and Dr. Laskar for being rapporteur for the session. And I also appreciate the good work being done by Dr. Mohapatra and Dr. Patnaik. And it's an honor for me to work with Dr. Patnaik previously as well on climate change and health. During next 8 months, 8 minutes, I will try to touch upon health aspects of winter systems. We will look at how body physiology is affected and its impact on diseases. We will look at common diseases which increase in cold weather. We will look at certain aggravating conditions. With these conditions, people suffer more. And then we will look at what can we do, preventive measures and care in these conditions. So what we know about impact on health, our body functioning, that is called physiology, gets affected. So we have especially the peripheral blood vessels in our extremities, our face, our hands, and our feet. They contract, they narrow down, and the blood supply to these parts gets reduced. So you feel your hands and feet are getting cold. And then the blood becomes more viscous, and then there is a possibility of this blood putting more load on our heart, and that is why in winter season you have relatively higher incidence, higher chances of getting heart attack, which is called myocardial infarction. And this effect on body physiology is more in women than in men. The body gets cooler and it may affect the body functions. You can also have frost nip on your fingers and your hands and frostbite. Because of isolation, staying indoors, you may have mental health issues coming up. There may be pre-existing health conditions such as arthritis, which may get worse. You may have impact through pathogens in environment. Some pathogens survive better in cold weather, like flu, cold, which occur in winter. And by staying indoors, you are more likely to get infected, and that is what we are seeing in the cold parts of the country. COVID cases have increased, and there is also some good news. Some of the vectors which spread disease, like malaria, dengue, they go into hibernation, or they become less common, and these diseases come down. Cold also affects our body immune system because of less blood supply in the extremities to preserve blood supply to the brain. Brain by weight constitutes only 2% of the body weight, but it takes 20% of oxygen. So it's very important for the brain to fully function, because that's the headquarter controlling all our body functions. Because of this, there are fewer white blood cells available. These white blood cells are the ones which fight infection in some parts of the body, and your immunity goes down. You are more susceptible to infection. And there are conditions which happen more in winter. All of us know cold and flu, etc., are more common. We have talked about colds and flu. common cold is more prevalent is actually the most prevalent disease in human being. It occurs 2 to 5 times a year in adults, and maybe 10 to 12 times in a year it may happen in school children. Influenza, which is a major killer of people in the older age group and those who are infirm. We also know sore throats happen more often in winter, and there are also some viruses which lead to vomiting and diarrhea, which happens in winter. Though diarrhea, vomiting, and other intestinal diseases are more common in summer. Asthma, respiratory problems also increase in winter. Extreme cold can lead to frostnip. The blood supply to fingers and toes goes down. And if we don't take care of that, it becomes frostbite, and you may have to lose your limb if it is not attended to in time. You may have conditions like immersion foot or trench foot. It was first described in the army soldiers in the world wars and other wars. When you keep your limbs wet below 10 degrees Celsius, there is a possibility of your feet and fingers get affected, and you may have to lose them in case you don't take timely action. Hypothermia is a condition where body temperature goes, normal temperature is 37, it goes below 35 degrees Celsius, you are more likely to get infection. And in winter, you must have heard, in peak winter, you read in the newspaper every day, so many people died of cold. They die because of hypothermia. They get literally frozen on the roadside and do not make it after hypothermia. You may come across individual who may say, मुझे आपसे ज़्यादा ठंड लग रही है. I am feeling more cold than others. And then there is a need to contact the doctor to find out if you are suffering from anemia, you are suffering from a thyroid disease when thyroid slows down its functioning, called hypothyroidism. You may also have disease of the peripheral blood vessels called Raynaud's disease, which is more common in those who smoke. Diabetes may lead to diabetic nephropathy, kidneys get damaged, and you may feel more cold. And those who have eating disorder, which is called anorexia, their appetite goes away. These people are likely to feel the cold more than those who are normal. On mental health, people get isolated, and what we call is seasonal affective disorder. They may go into depression. In fact, suicide rates are higher in winter across the world. I was in Switzerland for more than 5 years in the UN. We used to see almost every day suicides happening because it is snowbound. People don't go out and they get into depression and commit suicide. So mental health is affected. And there is also a relationship with the daylight. On a sunny day, you feel better even if temperature is minus 20 or so. There is also good news. Like in agriculture, we heard there are good news. You get some winter crops, otherwise you won't get these crops if there is no winter. You have a reduction in some diseases, malaria, dengue, diarrheal diseases, some allergic disorders which are because of the pollens which occur in summer and change of season. These diseases are also less. And since the body needs more calories to keep it warm, and it's a good time for you to reduce your weight, but you have to also reduce food intake. If you increase food intake, then the net result will not be producing any weight loss.
2 minutes, please.
Sure, sir. There are 5 conditions we need to keep in mind. Air pollution, we heard, gets worse during winter. Then you have conditions like COVID, which have become worse in winter. Hand hygiene and respiratory etiquettes and respiratory infections. These can be handled if you wash your hands and follow other respiratory etiquettes. Children and elderly with chronic conditions like joint diseases, respiratory, cardiac conditions are affected more. If you are at high altitude in winter and you are visiting there, if you are not acclimatized, you can get a life-threatening condition called high altitude pulmonary edema. What can we do? You need to address the body physiological needs, dress yourself properly, Dressing is putting more layers of clothes, not just putting one thick cloth. Layers help you better. Then what else can you do in addition to more layers? Use heating and insulating devices at home. Prevent respiratory infection by frequent hand washing, and drink more hot fluids such as herbal teas. You may like to practice meditation and relaxation. Meet people, if not physically, maybe virtually, so that your mental state of mind is kept well. 5 things to do: clean your hands, we talked about it, eat healthy food and exercise regularly. Do not skip doctor visit if you develop a condition or you are suffering from a condition already. Get vaccinated, especially those of us who are in older age group. Flu shot is available. You also need in old age tetanus shots. You need shingles, which is the sleeping chickenpox virus in the body, which gets activated and is a very painful condition, especially those above 50. Then pneumococcal infections, you have a vaccine available. Those of us above 65 should get this vaccine. And beware of misinformation. There are a lot of immunity boosters, more so during COVID time. Taking steam, drinking hot water, etc., etc. Be careful about misinformation. It gives you false sense of protection. Manage your lifestyle better in cold weather and you will remain healthy. And if you want to look at my blog, it is available. You can send me an email for further discussion if you don't have time for that. And my Twitter handle is also given here. You can look at that. Thank you so much, Dr. Dash.
Yeah, Dr. Kumar, I don't find again any question for you on the chat box. Maybe it will come later on, because now I find one question for Dr. Anna. So please, I will request all the speakers to be there so that at the end, maybe a couple of questions we can discuss. For now, I have a question for you, Dr. Kumar. What is, from your long experience, can you tell whether really COVID-19 is dependent on temperature? So many papers are coming, then contradictions and things like that. Very briefly, what do you think?
Thank you, Dr. Dash. This question has been asked many times. And the COVID, first is we need to know COVID is a new disease. Nobody knew about it till about 12 months back. So we are learning about it. Because of cold weather, people tend to stay indoors. So that is one reason why it can transmit from one person to the other. And the virus survives longer in colder temperatures. So these are the two reasons because of which you see increase in COVID cases in winter time.
Thank you very much. Now I request Dr. P.P. Singh. Now I request Dr. P.P. Singh to talk about the aviation, winter weather and aviation. Dr. Singh, please.
Thank you, sir. Can you hear me?
Can you please share your slides?
I have given it with you. If you could share them with me, Dr. Patnaik will have them.
Acha, okay. Dr. Patnaik, please.
Let me share. Okay, sir. Just a minute.
Probably you can start sharing, so you can just. Yeah.
I will just give my introduction. Good afternoon, everyone. My name is P.P. Singh, and I'm head of the airside operations, the chief airside officer at IJ Airport. When I say airside, this means the area beyond the terminal building, the runways, the taxiways, and the aprons. Of course, the winter operations, as it is known as worldwide, affect both the terminal building as well as the airside. But aviation, yes, gets affected by winter in the terms in India, as far as we are concerned, and more so in North India, are the low visibility operations. That is, the onset of fog season impacts the operations of airports or aviation in general. So what we do is we conduct the low visibility operations at the airports. Mainly these are New Delhi, Srinagar, Lucknow, Amritsar, Jaipur. These are the airports that get affected by low visibility operations. We have even heard of an airport like Bangalore getting affected due to low visibility. Can we shift the slide, sir? Yeah, so What is the impact on aviation? As I just told you, we conduct low visibility operations. Now, to conduct these low visibility operations, we need the communication and navigation infrastructure. That is the instrument landing system with which the aircraft can land in low visibility. The airfield ground infrastructure, that means the lighting, the airfield lighting. The terminal infrastructure would mean more seating capacity, more toilets, more manpower, help desks. Equipment in aircraft would mean that the aircraft have to be compatible to operate in the low visibility. You must have heard of Cat 3 operations, ILS, Cat 1, Cat 2, Cat 3. What do they mean? And then the training of the pilots. So it is not only that the aircraft has to be equipped and the ground operation, the airfield infrastructure, but the pilots also have to be trained. So one pilot ABC has to be trained on that particular machine to operate at the low visibility of procedures with Delhi airport or any other airport. So this is the impact innovation. Next slide, please.
Yeah,
Next
already
slide.
I moved. Yeah.
Okay, so what happens now is, yes, what is the impact? We get flight cancellations, we get flight diversions. All of you must have traveled. We have terminal building congestions because when the flights get cancelled and when there are diversions, people have come from their homes but remain in the building. We have apron and parking stand congestions. There are times when the arrivals happen and the departures do not happen because the arrival minima is 50 meters and the departure minima is 125 meters. When I say minima, these is the minima of the visibility on runway. You are familiar with the general visibility, but the airport operates with what is the visibility on the runway. That means how far a pilot
It is.
It okay?
Is there any problem?
I think linkage
Dr.
with
Singh?
him. That's
Dr. Singh? Is there any problem? We can't hear you.
yeah. I think there is. Yeah, we can't hear him.
Do you have his number, Dr. Patnaik?
Yeah, yes, sir. Let me speak.
Yeah, ask him to switch his off his video and switch on mic.
Yeah, yes, sir.
Did you talk to him, Dr.
Problem,
Patnaik?
sir? No, because no, we are not able to hear you after second slides.
I don't see him speaking also.
Network, you can switch off the video. So then video you can switch off. Otherwise you can re-log in again. Yeah, please do it.
Hello.
Yeah, I have spoken to him. So I think there is some connection issue. So now he doing again. Let us see.
Probably to connect again, join again.
Yeah, I think he may have to join again. That already I
Otherwise, otherwise you will go to Dr. Alok Kumar.
Yeah, that also possible.
You just scroll over his slides and let.
Okay, let me have a talk with chat with him just once again. If he's doing, otherwise we can go to next figure and we can take this afterward. Just.
Yeah, we'll see whether we'll take it later on. Okay, Dr. Singh.
I am speaking to him just.
Hello, Dr. Singh.
So I am just calling him. Could you able to do it again? No. So what we are doing? Just you log out and log in again. In the meantime, we are taking the other speaker. That's yeah, okay. But when you are ready, please inform me. Okay. So, sir, we can go for other speaker. Let us see. So, I'll stop
Okay,
sharing.
Dr. Alok Kumar, please. Dr. Alok Kumar, are you ready? Dr. Alok Kumar, I can see you. But
Yeah,
your slides are, you have shared your slides.
Yeah, he has shared.
Yeah, please. Yeah, thank you.
Sir, you are mute. Yes.
Alok Kumar, you are mute.
You are mute.
Yes, sir. Now I'm audible.
Yeah, now it is okay. Fine, perfectly fine.
Please go ahead.
Yeah,
8
sir,
minutes. After 8 minutes, I will just signal you.
I'll try to complete within 8 minutes. Yeah, I'll take you through the presentation and I'll give you some numbers. Sir, can you switch on your video, sir? Switch off your video, sir. That's sir. Yeah, thank you. We are the first, we are the largest synchronous grid in the world. And in electricity generation, consumption, installed generation capacity, and transmission system, we are number 3 in the world. As far as wind generation is concerned, we are number 5. As for solar generation, we are number 6. And as for hydro generation, we are number 7 in the world. These are just the statistics, the numbers I wanted to share before I start on my presentation. And these are the dimensions, just the numbers. Again, 356 gigawatt of power generation capacity India has had. Around 185 gigawatt peak demand we have made so far. And these are the kind of numbers, maybe 410,000 circuit kilometers of extra high voltage transmission lines. Around 86, the numbers are slightly old, 85, 86 gigawatt of renewables already in our system. There are more than 50,000 market transactions and 3 gigawatt of international exchange from other countries, Bhutan, Nepal, and all other countries. 6,000 plus market participants are there in the country. So it's one of the largest synchronous grid, largest grid in the world. And what we stand as the system operators, POSOCO. These are the power sector governance mainly. The policy making is done by central government, central city authority, and these are the regulators. And we are the system operators, basically the brain of the country which runs the whole power system. And we coordinate with generators, transmission systems, distribution, and all the markets, power exchanges, trading licenses, everybody. So basically, POSOCO works as a brain of the power system of India. So we operate through 5 regional load dispatch centers and 1 national load dispatch center in Delhi. And we discharge mission critical statutory function of national importance of the country. And sir, coming to this is just the demand pattern I am showing you on my screen. This is the summer left side, summer demand pattern. You can see this in the morning hours. This is a time 24 hours a day. This is the morning hours. The demand is slightly less and it picks up like this. Evening around 18 hours, it goes like this. In the monsoon season, there is a slightly different pattern of demand of power consumption. In winters, that what we are going to discuss today will have a different kind of altogether profile. The morning peak comes in a very early and is very sharp, as you can see here in this. These are the different 3D plots, typical all India demand, like morning it picks up. This is 3D, this is the date and this is the time. And you can see this is a morning peak. Again, there is a dip in demand and again it picks up in the evening peak. So these are the kind of typical demand we have in our country. The solar generation, this is time and this is date. So this is kind of curve we get for solar. And the daytime, this is the kind of generation we get. And this is what connections just before that I mentioned about with the other countries. So we are connected to Bangladesh, Myanmar, Bhutan, and Nepal. So coming to impact of weather and power system, in the peak summer, we have high temperatures that leads to increase in demand. Dust storms leads to load crash, high voltage. Monsoon period from July to September, there is widespread rains, and that leads to sudden load crash, that decrease in demand, and high voltage. One of the parameters that we monitor for the healthiness of the power system is frequency and high voltage. So we do, this is a localized phenomena, and we get high voltage in the grid. And sudden hydro generation outage due to high silt content that also takes place during monsoon season. Winter period from December to February, multiple element outage due to fog, smog, like aircrafts get affected. We do get affected due to this fog and smog, and tripping of elements or transmission lines took place due to snow also, in particularly in J&K area. Cyclones just now 2 days before, that also leads to power damage to the power outage, damage to the transmission system and distribution network. So very good forecast we got through our cyclone monitoring system, and we planned our activity in the last 2 days, and again the system has back to the normal. Solar eclipse, two incidents we saw in one in 2019 December, and this in June. And I'll just give a brief idea of also about this, how we could manage with the help of IMD and Positional Astronomy Center, Kolkata. So this is a typical demand pattern of North India I have just put in here, because we are highly affected by the temperature and or I'll say the weather. In the low demand period is normally in the winters, but the peak, the rise in the morning peak is very sharp, slightly different from the summers. Summers we have very high demand due to some paddy loads of northern India like Punjab, Haryana, UP. A lot of farming takes place. So that paddy load, AC load, that also comes in picture here. So high humidity, high temperature increases all this demand. So this is the kind of pattern we have for a year, I'll say. And this is the terms of megawatt for the northern India. And I said 185 gigawatt we have made for all India basis. And for northern, it is around 65 gigawatt. So this is typical load pattern. As you can see, the November, it is very much different from May, August, or these two summer periods, and in January. So you can see here, this is the pattern for 29th June 2020. This is the megawatt for 29th June. The variation is like from 60,000 in the night hours, 00 hours, to it is going again to some 60,000 plus in 14:30 hours. And again, evening peak is going down. And again, it is picking up once we are switching on the lights and all. But what is happening in the winters, though the demand is less, it is for 6 January 2020. As you can see here, when we get up in the morning, we switch on our lights, switch on geysers, everything comes up. And see this is the kind of peak we get. So it is 400 megawatt per 5 minutes. So all India basis, sometimes it goes to as high as 400 megawatt per minute on all India basis. So we had to plan and schedule the power generators according to this curve. So this becomes very important. Every 2 minutes, 3 minutes, we have to bring back a 200 megawatt machine in the grid. So all this planning is done based on this your information on or the requirement of the demand due to weather condition in the winters. So this is the kind of graph we have, and this is how based on this only we plan our generator cells here. So this is energy consumption for a year I have given for the northern India, and you can see this is in terms of million units. What that was the megawatt real time power, and this is a day wise power consumption for the whole day. So this is the kind of, so you can see here this in the January, February, March, it is slightly in the lower side, but in the summers it is very high, and it goes down after, starts tapering from September, and again it goes down to December. But when there is a rise, I mean there is a further fall in temperature, some heating load comes here somewhere after 15th December, and you can see this, there is a slight increase in generation, I mean in power demand. And similarly for hydro generation, see in a summer months the inflow is very high, so we get around 350 million units or 400 million units of generation from hydro plants. But once winter picks up, winter picks up, this goes down. So this is the kind of impact is there on the generation also. This fog that we monitor through satellite images, color composite images, and this fog leads to tripping of lines that I explained in the beginning itself. And here we'll see this. There was this insulators that in the power line that due to moist air in foggy conditions, the insulation level goes down and it leads to tripping. So these are the different incidences. Just I have mentioned of 2017-18 or 765 kV trunk lines got tripped. So this is the kind of tripping occurs due to fog, and this is the power flow in this chart. You see this is 1000 megawatt. This transmission line was carrying, and it tripped here due to fog. So what happened? The other lines, the parallel lines which were carrying power in the range of 400 megawatt, this got overloaded because the power flow from this line got distributed on other lines. So this was now carrying more power than the desired limit. So it could have led to some kind of threat to the grid security. So this is the scenario that we face in due to winter season, and we use this forecast from IMD, and in real time also we monitor this forecast, and we try to track the zone, in which zone the fog is there and which lines can probably trip. So accordingly we take some action, like we minimize the flow on those lines which can trip, and so like by managing our generators, reducing the generator in one complex, increasing the generator in other complex, generation in the other complex, we try to manage flow on these transmission lines. So that is the kind of use that we take from your fog forecast. And this is one plot that is for solar eclipse of 26 December 2019. So this solar generation also, there is you can see this due to fog, it picks up late. Otherwise, it could have gone like this here. I think I'm able to show on the cursor. So on 26 December also, this green line, this was some deviation from the path, from this dotted path, just because of fog in the North India, some Western Rajasthan area, and cloud in the southern region. So, and this was the power generation due to impact of eclipse, and otherwise it could have been like this only coming from the solar generation. So this was the impact, and we analyzed this how this is going to behave based on the data provided by IMD of Trivandrum radiation of 2010 solar eclipse. So that was very helpful in analyzing this impact, and because the solar penetration has increased a lot in the country. So this has been used by, in the international forum also, we have published a report also on this. So the snowfall also affects our transmission network. As you can see, this is some incident of Kashmir of 7th Feb 2019. Heavy snowfall leads to transmission line outage. And in the Kashmir Valley on 7th and 8th November, there was a complete interruption of power supply in the Kashmir Valley, including generation loss of around 150 to 200 megawatt at Kishan Ganga NHPC power plant, and 80 megawatt at state-owned generation. And the valley was like, we took around 3 to 4 days to completely restore this supply to the valley. So this has all, snowfall has this impact on the distribution and transmission system, because we need to do a lot of tree cutting before actually the snowfalls takes place. So last year it came a bit early, and the J&K department was like, it was caught unaware of that, and that led to some tripping and all. So further, for association with IMD, we are working and we are trying to put power system network on all these weather parameters for weather visualization, and I am sure that this is going to help us a lot in managing the whole system. So thank you so much, sir. Any questions? I'm there to answer you.
Yeah, thank you, Dr. Kumar. But you know that wind energy is coming up in a big way, and there are so many companies which are generating that, and they want to know about the wind intensity and direction, all this information. So what is your view about this seasonal changes on this wind energy?
Sir, I have not shown any plot on that, but yes, it does. From August, September, October, there's a high wind season normally, and the generation is more from those plants, and now at present the generation is less from those plants. So yes, they are demanding, and they're demanding at the hub height also. So the machines are connected at 110 meters or 90 meters. So that wind speed is required at that level and direction also. So and there is a particular characteristics. There is a power curve of wind generation where it starts generating at 4 meter per second and generates up to 20 meter per second. After that, it goes into cutoff mode also. And below 4 meter per second, it also doesn't generate. So there is a curve in that. Based on that, it generates. So yes, there's accurate forecast of the wind at hub height level is very much necessary to accurately forecast generation from wind planes.
So as a community, we have to be ready because there will be more and more demand.
Yes, sir. Yes, sir. Solar irradiance forecast, wind forecast. Even I'll say that the snow monitoring, what Dr. Sekhar was very nice. I'll like to have that information also. That other JNK, the situation like JNK, what happened last year should not come, and we should be more prepared. Like cyclone, we are very much prepared now. We really track through radar, through satellite. We have with interaction with IMD and different workshops. We have learned also, the system operators at our place have learned that, and based on that information we are using to save our infrastructure also.
Okay, thank you so much. It is so informative. Thank you very much. Now, I think we have to go back to Dr. Singh. Is he available? Dr. Patnaik? Dr. Singh is available now?
Just now I spoke to him 5 minutes before, then he was still having some issue. So he said, once again, let me try. In the meantime, there are some other questions, then we can take up from other.
Yeah, so what I heard from you is that Wing Commander Satyam Kuswa is not available. Yeah. So probably what we can do is that all the rest of the speakers are available here.
Hear you now.
So
I can hear you.
Who are communicated, they can speak.
I can hear you now.
Let us have a discussion, and next 10 minutes, if there are
I think there is some connectivity with Dr. Singh, PP Singh.
Dr. Singh, please.
Can you hear me now, sir?
Please.
Yeah,
can you hear me now?
Yeah.
Continue.
Okay, can you put my slides on, sir?
Please continue.
Okay, I'm putting a slides.
Yeah. Once, let me say the slides and I'll start speaking.
Is it okay now? Slide visible?
Not yet, sir.
Not yet.
So DD,
okay,
yeah,
let me share. So
yet,
once
sir.
again, let me share. Now it is visible?
Yes, sir. So the impact on aviation is flight cancellations, there are diversions, the terminal building gets congested, the apron parking stands get congested because sometimes there are more aircraft on ground than the number of stands. As the landing minimas are lesser, an aircraft can land at 50 meters RVR but can only depart with 125 meters of runway visual range. So as a result, flights keep coming in but they don't depart. Then there is sometimes also an increase in safety incidents because of low visibility. The aircraft or the vehicles can hit other vehicles on apron, and this is the impact that aviation gets affected. Next slide, sir. Now, what are the special requirements that we need to operate in low visibility? The vehicles that move or the jeeps which provide follow me to the aircraft need to be GPS and transponder enabled. When we have a transponder, that means the air traffic control can on the radar monitor the movement of the aircraft as well as the vehicles. Various equipment or the airfield ground lighting and CNS are tested every time before the onset of the season. We need additional manpower. The entire staff gets familiarization and retraining every year. Then we need to deploy additional staff in terminals, on the help desk, in the toilets, because of the load increase during critical periods of cancellations. We need to have additional seating capacity when the flights gets delayed or there are diversions, passengers get stuck. So we need additional trolleys, we need additional chairs. Then we need additional food and beverage because suddenly there is a cancellation flight and 200 people have to be served refreshments. So the food and beverage stalls need to gear up for these kind of conditions. And of course, you need special help desk to guide the visitors and passengers on the updated flight information. Next, sir. Now the India is probably has one of the highest hours of low visibility operations. In the last year, we had 227 years. Previous year was slightly better, but on an average, we have, you see, 2016 and 17, 488 hours of low visibility operations. Now, when do low visibility operations actually start? When the visibility falls or there is a trend for the visibility to go down below 1300 meters. I'm talking about general visibility. Then the safeguarding takes place. That means the airport is safeguarded to ensure that it is ready for low visibility. And when the RVR or the runway visual range of any runway goes below 800 meters, then the airport goes into low visibility operations. So the last year was slightly better, 227. We are one of the highest airports with almost 300 hours of low visibility operations in the world on an average. Next slide, sir. You see the number of flights that operate during low visibility. Last year, almost 13,918 flights operated in low visibility compared to the previous years. In 2016, of course, the number of flights were higher. As we are progressing, I'm talking about 20 years back, the pilots were not trained, we were not Cat 3, and the aircraft not equipped. So we used to hear many cancellations. Now, as the technology is improving, we find that more and more aircraft, more and more airlines are operating under low visibility conditions. So that means there is a reduction in cancellations, there is a reduction in diversions, the pilots are trained, the aircraft are equipped, and the airports are also equipped to handle aircraft in low visibility operations. This has come down after very strict regulations from our regulator, the Director General of Civil Aviation, who has ensured that there should not be or minimum disruptions should happen during the low visibility operations. Can I see the next slide, sir? So number of flights cancelled during low visibility. Last year we had 145 cancellations. Prior to that, there were only 22 cancellations because the number of hours was less. So if you see the year 2016, only 22 cancellations. Why more cancellations in 19, 20? Because the number of flights that we are operating is much higher. You would be informed that IGI airport is now the 11th or 12th busiest airport in the world. So we handle 70 million passengers per year. So as a result, the number of cancellations were slightly higher, but the percentage almost remains the same. Next slide, sir. So these are the diversions. As you see, the diversions were 107 last year compared to the 39 or 125 in the previous year. So every year the diversions, I'm talking about, if you say 20 years back, the airport used to be standstill for 8 to 10 years. But now these are the diversions to the airports that are close by. The domestic flights get diverted to sometimes Ahmedabad or Jaipur if the visibility is good. But these days, generally you have Varanasi as well as Amritsar or Jaipur, all having similar visibility conditions. The international flights get diverted to Mumbai or Karachi because those are the alternate airports. Next slide, sir. So what the conclusion is that winter operations or the onset of the winter season basically has an impact in 4 fields. Number one, it disrupts the airline schedules. Things go haywire. The airports and the airlines bear additional infrastructure and cost because to train pilots, to gear up the aircraft, to gear up the airfield, deploy additional manpower, all this costs money. So there is a huge cost to the airports and to the airlines to operate during these winter season or low visibility conditions. And thirdly, inconvenience to passengers or public. People miss their onward connections, people miss their important meetings, people get stranded in transit flights when they are coming from one place and are moving towards another. If there are cancellations, they miss their onward connections. So these are the general impact on people and an airport. And of course, additional staff and additional man hours leads to additional cost to the airports. And lastly, what is our expectations? Last slide, sir. The expectations is that we need accurate forecast. Although the quality of forecast over the period of time has considerably improved, but at times also we get a forecast that tomorrow there is going to be fog, and sometimes the information is very generalist and not very specific. And timely availability of information is what is required, that when there is a fog, we must get information on time that okay, for this is the season, this is how the date will start. Although I know that it is taken on averages of the previous year, we do get daily information bulletin from our airport met setup, but the more accurate is, the better it is for the airlines. And lastly, the continuous updates on the weather is required during the winter season, so that we are able to inform our stakeholders, passengers and airlines, so that their inconvenience is minimized. With this, I end my presentation. I hope I abided by the time. Thank you very much. If there are any questions, I'll be delighted to answer. Thank you, sir.
Yeah, thank you, Dr. Singh. Thank you very much. I thank all the 4 speakers. Now, I think floor is open. You can ask in 5 minutes left. In next 5 minutes, we can have a couple of questions to any of these 4 speakers.
Sir, can I ask sir one thing?
Sure.
Yeah. So it is just to the current speaker, the PP Singh sir. As you said, you need some forecast, still improvement in forecast. So, means it is with respect to accuracy in location or time also you need. What exactly you need extra from the present what you are getting?
We thank you very much, sir. Thank you for your question. What we need is that the time. Okay, when will we generally get that cat 1, cat 2, cat 3 type of fog will come, high fog, very thick dense fog. So what we need is the time that okay, the fog onset will be at 12 o'clock, 2 o'clock, 3 o'clock. Sometimes we often get bulletins that there will be very thick fog, but as a result there is very little fog. So accuracy of information regarding the timing and the density of the fog is what we are looking for, because our operations depend upon the whether it is a very thick fog or a light fog.
Yeah, okay. Sir, okay, so there is one question to the Rana sir. He is available, Dr. Rana?
He has already answered, but he can now. Dr. Asrit asked him the forecast, and he also answered. But if he is available, he can discuss that.
Yes.
He can tell himself.
Yeah.
Dr. Rana is available?
Yes, available, sir.
Yeah, yes, one
So
specific
you can
question.
explain.
Yeah, so actually we are working with some group that they are doing some potato research center somewhere. So actually they were taking our forecast also. Then we actually wanted to see how this variation in maximum minimum temperature forecast for next 30 days is going to help something during. So is it there is a concrete results there? That means it can affect the forecast can be very much useful for particularly this winter crop. So is there any report or anything concretely available? Means we can conclusively show that this forecast by using the forecast for let us say 4 weeks, it is quite useful for real time or something like that.
Yes, sir. Actually, CPRI they have developed some potato cast also. One module they have developed in which we can put the maximum temperature, minimum temperature, rainfall, and humidity, and we will get that there is every likely chances of getting the late blight of the potato, which generally appears immediately after the this winter season is just start of the March and April. The moment we are having more than 85% humidity and high temperatures, so that disease can be predicted. Similarly, the other diseases also, they can also be managed if we are having maximum minimum temperature and rainfall forecast, because the rainfall forecast contributes toward the humidity and maximum minimum temperature when we get the summer relations. So we have for the this kharif season crop some cast, but for the potato crop we are using the potato cast of the CPRI. They have developed this module. And in case of this livestock and fishery sector, I have mentioned here that livestock sector generally is having 8 to 28 degree. It is a comfortable temperature. And the moment there is a variation in the temperature, 1 degree variation in the temperature, minus degree, the 1% increase in the feed is there. That is a general rule. And if there is a 10 degree deviation in the temperature, around 10% increase in the feed is required to have a maximum productivity. Specifically during this winter season, this broiler is one of the important, it is a business, many majority people, they do some business. So in order to have a maximum productivity, the moment we get the low temperature forecast, we increase the feed also. But if we see the fisheries stop taking feed even when the temperature goes beyond less than 4 degree of the water temperatures. So in order to save the feed and in order to increase the productivity of the poultry and the animal, that livestock or the milk productions, these forecasts they can be successfully used. We are using it. We are operationally using these forecasts. Thank you, sir.
अच्छा
Okay. Thank you, Dr. Anna.
Thank you, sir.
It's just 5 o'clock.
ओके ओके
So
ठीक है ठीक
I thank all the speakers, 4 speakers, and also the discussion, especially although the chat is not extensively used, I hope that the participants will connect to these speakers and they can send their questions to them and discuss also in future that is the part of one of the objectives of this type of webinar. With these things, I thank all the speakers and thank you for your patience. Now over to Dr. Patnaik for the next program.
Yeah. So thank you, Das sir, for nicely chairing the session. And we are actually in time, really 5 o'clock was the target, and we are closing at 5 o'clock this session. And so thank you to sir and also to all speakers. Now, as per the program, yeah, it is just either because our from the YouTube, since it was also in the YouTube, so some of the questions have come from YouTube channel. So Dr. Anand has noted some of the questions. And I got a call from DGM sir. DGM sir probably is some busy. So our other Vice President Anand Sharma is available. He will also coordinate this session, chair the session. And I'll request Anand Sharma ji to please have a session, and also request Anand Das. Yeah, he can display some questions. Anand. Dr. Anand? Yeah. Do you have noted or something? You what? But I think first, Dr. Asit available? No.
You should have told them to stay. Then they would have. Yeah.
Yeah, he there.
Yeah, thank you. If I have rightly understood, you are telling a cold surge coming from Mediterranean is called WD. Am I right? Yeah. So, in my opinion, no. Cold surge, if a cold wave is coming from western side, in my opinion, it cannot be a WD. Now, with the evolution of research, WD is quite a well-established function as far as dynamics and thermodynamics is concerned. So cold surge cannot be a part of this. Yes, you can say that ahead of it or wake of it, you have some cold wind or cold type of situations are coming. Most probably that could be the case. Thank you very much. Winter weather doesn't go very rarely there. Of course, winter, it depends on how seasonality you are defining. It depends on the regional micro scale climate also. If you are specifically looking at the winter transition towards the eastern region of India, so western disturbance occur there, but they are very rarest of rare. They reach that far, because by the time they travel that far, they leave their strengthening dynamics. So there is very rare cases that Sundarban has influence of the winter weather. If you are talking of winter weather, which is coming linked to the western disturbances, so that is not traveling that far, sir. Is it to me or somebody else?
Anybody can answer.
What briefly, fog modeling in particular, I have not worked on fog modeling that per se, but yes, we have worked. Our research students have worked for the visibility context of the fog, linking visibility to the fog as such. So in that case, yes, in winters we see that fog has the missing quotient in the fog research discussion is people are not talking of the land use changes and the meteorological impedance, which we have already published this work, where we found that surface wind in the winter time, they have become easterly. So by virtue of the skyscrapers, in particularly over Delhi and NCR, the U10 or V10 winds are almost dampened. So it has a meteorological impedance which we have observed from 1990 onwards in the reanalysis data. If you look at the surface wind, and by virtue of this impedance, meteorological impedance, there is a mixing is not possible. So your fog days are increasing, which I have also shown in one slide. After 1990, the days are increasing in that sense. As far as modeling is concerned, we have, as far as fog is concerned, we have yet to see how good the models are, in particular for the fog forecast. And just now we have heard Dr. Singh, who was talking of the airport nowcasting contacts, or maybe some India Meteorological Department, Dr. Anand is there, so, or Patnaik is there. Maybe they can give more light on this fog modeling as far as operational forecast is concerned. Thank you very much.
Yeah, yes, that. Yes. Doctor Anand, do you have any questions?
Just a minute, Patnaik, I would like to add something to that WT.
I was about to request you. Yes. That's I don't know.
As Dr. Dimri said, somebody has asked about WT. Yeah, it's rare, but many times it has been seen even up to Trivandrum, Pune, WT effects. So yeah, rare cases, it can be, if it's a deep trough, it can have a tremendous impact even up to southern India and maybe even the West Bengal as well. But very rare cases. Yes, that's what I wanted to add. Thank you.
Yeah, Anand, do you have any more question or anything? Yeah. Okay. One question to Professor Sanjeev Kumar sir. He just sir was there, but he left us some. Dr. Sanjeev Kumar ji, sir. Actually, my during your talk, because this is common question only, because you said कि if you wear more number of cloths, it may be thinner, it is good. then thicker one. So it's like how it actually, because that we'll advise our children to do that one.
Yes, yes. No, a very, very important question. Actually, I didn't know this even being a doctor when I went to Geneva. We took thick woolen sweaters and clothes. And when we reached there, the cold wind, temperature went up to -17, was almost piercing through the clothes to our body. And we talked to the local people. So they said you should have more layers of clothes, even if it is not a woolen cloth. And the outermost layer should be a wind cheater. So that the air doesn't go in. Otherwise, you really get chilled within a few minutes. So it's not important to wear thick sweaters and thick woolen dresses. It's more important to have dresses, and the outermost layer in cold weather, preferably, should be a waterproof cloth.
Yeah, that is good.
Thank you,
In fact, air layers help. Air layers between the clothes that gives the protection from the cold.
Very right. It
So
makes
there
an
should be more light.
insulation between the clothes because of the air which is trapped. Very right, Dr. Dash.
Exactly. We experience that every day. Every day we experience that. And when you are abroad in cold countries, you might have seen that many people wear 2-3 layers and remove one after another after coming inside the room. So outside you have 3 layers, but inside you have 1 or 2 layers.
Very right. That's a standard practice. When you enter somebody's house in colder parts of the world, you have a cloth hanger. You take out your outer layer of clothes, hang it there, and then you walk into the house. So it's very common practice. I agree with Dr. Dash.
Yeah. Thank you, sir, for this.
I think, sir, it is because of the pollution also. Because due to high voltage, this gets ionized into plus and minus. So that basically creates a conducting path. So moist in the sense, I mean, that doesn't affect much. Because we have a certain distance also we maintain in power lines.
Yeah.
No, sir. In winter times, this solar generation, I mean, is like it is mostly located in Rajasthan, like or Karnataka or Maharashtra as of now. So in Rajasthan also, the fog incidents are slightly lesser. It is not in Delhi, or it is lesser in Punjab and Haryana. UP. It is coming up there. So when we look at the generation is not coming up, then we try to have some other source of generation in place of that. So that we plan, sir. So that's why the forecast resolution time we do demand for a lesser interval, like 1 hour, half an hour or so. So that is the reason, sir.
Okay. Yeah.
I hope I have answered, sir.
Yeah. So, Sarmaji, so your comments are because you are also experienced. You have worked in many northern centers, northern Indian centers. So, Anand Sarmaji, please.
Hello. Yes.
Yeah. Please. Your valuable comments, because you already have worked in several. You are also involved in IMS activity. So before we go for formal closing vote of thanks, so I need your valuable comments and everything on this today's.
No, fantastic. First thing is that it's very good. I mean, a very successful seminar, webinar, and the topics, all the speakers was superb. I mean, I was listening to them right from power sector to aviation to agriculture to mountain meteorology by Demery. Professor Sanjeev Kumar ji, Jay Kumar, Ranbir Singh Rana, PP Singh ji. Everyone was fantastic. And, they have touched the real practical issues. And only thing is that, yes, IMD is doing a great job. IMD is providing very timely weather, advisories, forecasts, and warnings. But yes, we also need to do more. And I think there are certain issues that lead to modeling like fog and other things where more, research and practical models are required. So I'm hopeful, IMD has stood to all the challenges up till now, and we will definitely, so if the kind of feedback we are getting from all our, participants, I think we will have to work hard. So our NWP unit already is doing great job along with the NCMR, WF and IITM support. And the ministry is also, our Rajiv sir is very guiding force behind this, and DG Saab is also very dynamic. So I'm sure, and the kind of initiative IMS has taken. So what I find these days is that there is a synergy. So the best thing was earlier was missing was that the synergy between MOES and various sister organizations like ITNCMW and IMS. So that kind of synergy is now there. All of us are working as a team, as a family. So, and our other sister organizations and our users, they are also, they are also contributing a lot and giving us more and more targets to achieve. And I'm sure we will be able to come to their expectations. I'm really happy. It was a fantastic seminar. Thank you. Thank you.
Yeah.
Thank you. Thank you so much.
Dr. Patnaik.
Yes, sir.
I would like to ask question from health sector and aviation sector and power sector. With agriculture, we are okay. What is the use and how what they feel to use about 2 week or seasonal forecast or extended end forecast? Because whatever they have shown is just for a daily or 2-day forecast or something like that. But whether the forecast, weekly forecast or 2-week, 3-week forecast or season as a whole forecast, how it can be useful for say power sector and health sector and aviation sector. So maybe first from
let us say power sector. Let us say that.
Yeah, sir. The thing is how this power demand is made for a particular state. Suppose I am taking a state of UP. So they have got some long-term contracts with different power sources in the country. Suppose the power demand is 15,000 megawatt. So this long-term contract is maybe for suppose 18,000 megawatt, right? So there is a still suppose shortage of 1,000 megawatt, and I am planning for next 3 months. So what is there? There are different products in for bilateral contracts that we say short-term open access. So UP can go to the market or have a bilateral contract with anybody in 3 months in advance, considering its demand. So how he'll forecast his demand based on your medium range forecast, like for what you have forecasted for the upcoming season, 15 days, 2 months, 3 months. What has been forecasted, based on that, he will, and based on past experience, both, he will make a calculation that, okay, I may need 700 megawatt of power during the month of November, and he's sitting in, suppose, in September. So he'll go for a bilateral contract with certain parties, and that demand he will try to make up. So like there are 3 layers. One is long-term contract. So what he has done is like 18,000 megawatt. There is some 700 megawatt. He did it in 3 months in advance, right, sir? And before day ahead or maybe 2 days before, he will see the real-time scenario. So he'll go in the power exchange in 24 hours in advance. So in power exchange also he can buy, or even he has surplus, he can sell. Right, sir? And there is one more thing. There is a 2-hourly real-time market also. So every 2 hour that market now operates. It has started from 1st of June this year, 2020. So still I have some shortage, or I have suppose more wind generation and I don't have requirement, I can go in the market and sell. So that also depends on the weather. So that also is looked after by the planner. There are three kind of plannings are now. One is long term, like for 25 years they have already done some contract. Like other is like for next 3 months, maybe some short term bilateral contracts. And like for a day ahead, there is a power exchange. From there also they purchase or sell. It can be both way. And in the real time market, maybe 2 hours in advance. So this all, and demand is like totally, it totally varies on based on the weather. So this is the way it is done, sir, in power sector. And this is the use, sir.
Why I asked that we have not received any demand from power sector that they want specifically this forecast or that forecast, something like that. Because we are giving general forecast, but a specific forecast to power sector or health sector or aviation sector.
Sir, we have submitted, sir. We have submitted, sir. Next has all the information.
On health sector, there are 4 major areas where this forecast is being used, but there is a scope for increasing the use of this in planning and preparedness better. 2 of them are meant at family level. When you have people who are more vulnerable and have the chronic diseases I mentioned earlier, you need to look at weather forecast in coming days and can use it in preparation at home. Second area where families and individual can use it, when you are going away on travel, look at the weather condition of the place you are visiting and the forecast helps you. And those of us who have been doing a lot of international travel, we routinely look at it and we need to look at it within the country. Second component is how the health system can use this information. We have recently seen that before winter came, it was mentioned in the media and also by the policy planner that we are going to see an increase in COVID cases. Winter is coming. Similarly, you have flu coming in, you have common cold coming in. You can prepare for that as health system that we are going to see more cases of these diseases. System needs to be prepared for that. And especially those institutions and those departments in the health sector which are taking care of the most vulnerable population, that is elderly, children, and also those with chronic disease condition, they can stock up the supplies in advance because more cases are going to come, and even those cases who have a long standing disease are going to have an increase in the disease condition situation. Need for example analgesics, pain relieving medicines, etc. is likely to go up. But certainly I agree with you, there is a scope for increasing use of this forecast. One is predicting the forecast by the weather experts. Second is use of the forecast by health system and also by families in taking care of their own health and health of the families. Thank you, sir.
Yeah, one more question I would like to ask Professor Sanjeev Kumar ji. I think there is a need for now a forecast for allergens. A lot of allergens, especially the pollen grains. In certain cities like Bangalore and other cities in certain seasons, the pollen grains suddenly increase, and weather conditions are very, very important for that. And I think up till now we have not started, and I think it can be started. First thing is that we know the kind of vegetation growing in a particular city. We know their flowering time, and we also know the temperatures, and we can predict the flowering. So when we know that the heat units, it is based on the heat units. If those particular heat units are completed, the plant will start flowering. So that means now the pollens will be available. So this kind of forecast, I think nobody has started this. I took an initiative in Dehradun when I was posted and with the medical college over there, but somehow I've got transferred. So I think this kind of initiative is required in the various cities.
I fully agree with you, sir. When I moved to Jaipur on joining UNICEF, one of my children started having a lot of asthma-like problem. And we looked around and we found out from people there is a weed called Congress grass.
Congress grass. Yes.
I don't know how it got its name, but then we went around. There were many vacant plots. We hired labor to go around and cut that weed and take it away. And I didn't know about it till we started suffering. So there is no system of forecasting.
Correct.
And there is no system of a new arrival to know what kind of allergens are there. I fully agree with you, sir. We need to work together between
Yes.
health and weather experts to forecast these so that we are prepared as individuals and also the health system. Thank you, sir.
Thank you.
Sahaya Saab, any question, Sahaya Saab?
No, it is fine. Okay.
Yeah.
Thank you.
So, is there any question or any comments before we formally give vote of thanks? Is there any specific question or comments to speaker, or we can pass on to that? And as already Anand told, we are collecting and we'll put all the PPT in at least in IMS website. That we have done last time also, so that in further interaction they can do it. If there is no question, anything, so it is my great pleasure to give formal vote of thanks to all. First of all, let us thank to our DG and also the President IMS. Because of his support, we could able to do it. And this, since IMS activity last 8-9 months we are not doing because of this COVID situation. So you wanted to do some activity also by integrating this virtual, all the institutions through virtual network. And the first thing was, this is the winter season, we started this thing, and this activity will continue. So first of all, let me thank to all the speakers. Sanjay Kumar sir is there with very short notice, with very short, because it was planned in just 1 week before. So it was, time was very short, and we were approaching many, and we could get the good specialist, Dr. Sanjay Kumar sir. Thank you very much. And also Alok Kumar ji, whenever we request him for any such event, so he agrees. So that is very good, sir. We are really, we want to enhance the collaboration, IMS, IMD, and the sectoral application, because our target now is power. And agriculture, already the IMD and IMS organize many events, and IMD already engaged in agro-advisory, one of the best in the world. But now this focus was how this winter we want to enter into certain, and we have to expand our services. So IMS can also little bit play a role to enhance the capability of IMD through this networking and through the collaboration. That's why we specifically invited the, how the winter weather, and Palampur was the best agricultural university located at the top, with a very cold place, and that's why we invited him, and Dr. Rana also agreed immediately. Thank you very much, sir. And our dial representative from GMR, he has given fairly a good idea how this flight diversion and how the requirement of little bit spatial and temporal accuracy in the forecast can help with the particularly the aviation sector. So I think with all these memoirs efforts, and IMD and IMS also can take a major role, is we will be able to serve this demand in future. So thank you very much, sir. And unfortunately, our the panel speaker for highway sector could not come because of some mother and father admitted in hospital. He was in hospital. We are trying to connect, but somehow it was not connected. And highway sector, because now we have also trying to go for highway sector, the train communication and road communication, because of during fog time. So that is another area where we can venture. So thank you to all the speakers and our technical speaker expert, Dr. Dimri, Dr. Sekhar, Dr. Asri, and Dr. Our Sachin Gude, and all this they have given good about the discussion about the modeling development that are taking place, so we can take up the future challenges. Thank you very much to all the speakers, and our IMS Vice President, Dr. Sahaya Saab, and the Anand Sharma ji, yes, they are also supporting IMS and guiding properly to do the more activity. Thank you to both of you also. And our past president, sir, Das sir, is always very active in climate service, and we have done many activities through IMS. So that's why we also requested him to chair this service, the impact sector, and that was so. Thank you very much, sir. And finally, all our viewers and all my colleagues from IMS, Dr. Anandas, Dr. Laskar, Dr. Giri, and many others, they have supported and constantly, because this is the first time we try to do. Somehow it was okay, I can say some successful, we have done it, but we will be doing such seminar, one hour seminar, just like one event frequently. Once it is successful, this virtual event, till actually we go for a physical event, we can continue this thing with good speaker, and with all the support from our national council members, we will be able to do, and we will do the justice to the Met community at least as a whole, by integrating all the institutions. And thank you very much, and all my finally thanks to all the viewers, those who are there and they are writing questions. They are very much interested in IMD activity, IMS activity, meteorological activity. So that question also helped for the interaction. And thank you very much. And thank you. And we will very shortly meet in some other virtual workshop or virtual seminar that we will be conducting after a discussion. And now, of course, we will be concentrating on our TropMed annual event that is going to happen on 14th to 17th December. So probably before that, if possible, we will have one lecture from IMS that we can think about it, and we will do it. Thank you very much.
Thank you. All the best.
Thank you, sir.